Yeah, so you can see here, if you've not noticed, if you haven't noticed yet on your training guide, each of these topics is hot linked. So if you wanted to look at, say, the geotech module menus under the modular menus, if you click there, it's going to take you to where you can see what those are about. There is no real go back to the beginning other than if your PDF viewer has a previous page kind of navigation that would work there. But give you an idea about a couple of these things here. When you see in the table of contents these red lines, those are the exercises. Okay, and so in this first section, point groups, break lines, and surface evaluation tools, and then putting it together in a workflow. These are some things that are really heavily focused on in the fundamentals class, okay, Kaylee, that you're going to see again later. Um, and that's sort of the front half of this. We're not going to spend a lot of time in there. And then once we go into the next section after that page, we talk about the civil module exercises. And here is a single roadway design, some grading tools. Um, let's see, let me go back to that. Um, so we talk about that. Now, each of these has, it's not just, stepping through an exercise, but here's starting with these design exercises, a little bit about, what we do, what we'll cover. Um, and then here starts the design exercise, but part of that exercise is some of the education. Okay, so it tells you right here the fundamentals, what we're typically need. Carlson's the three-dimensional design approach, and here's your stepwise approach. The four things that we have to have, and the fifth that we should have with it. And then here's the procedures. And once you see that procedures bit, that's going to step you through the actual steps of the exercise. Okay, and so we'll do that and discuss a lot of these tools along the way. Okay, and then here becomes the grading tools. And there's some of this design, what we're going to do. So there's not a whole lot of discussion on this one before we go right into the procedures. But way back up here in this first section, when we talk about, um, oops, sorry here, some important concepts. Let's see, surface and contour, terrain modeling, a bit of background, that sort of stuff. So this is, when we talk about terrain modeling, um, this is where the meat of what the Carlson software does in an automated sense is really discussed. And here's your basics. It talks about some triangulation, talks about what is a triangulated irregular network, or a TIN, that you can see in here. Um, and the importance of break lines, and shows you the difference. Right here's 4 points. If you don't have break lines defined, it is free to interpret this in one of two ways. If you think about that, if I look at the comparison, I don't, yeah. If you look at it like this, if it were to form, because this is really all surface modeling is a bunch of triangles edge to edge that form a continuum across the limits of our land. But look at the elevations here. And imagine if you had created these triangles on the ground, 110 feet up on these corners and 100 feet down, lower down here. Same thing over here, another one that's also 110 on these two corners down to 100 feet. Well, what shape is that? that's a, that's a saddle. That's here's a ridge line that's 10 feet higher than the points off to the sides, right? And if we look at, in comparison to that, the same 4 points, but if it forms in this fashion, I've got a triangle that's 100 feet and 100 feet and 110, but the points on the sides are higher than the points on the bottom. So this is a valley. It's not a ridge. This is the low part of that feature with the high parts above it. So you can see the vast difference that those two interpretations can make in our data. Okay, I can either have water filling up this part of my site where it rains in on this high stuff and drains down into here, or I can have my site, if it goes this way, shedding all of my water and pushing it off to the sides. And that can make a very big difference in how we treat this data. So that's the type of discussion that's here in this part of this upfront part of the manual. Another very practical example of break lines, how triangles form and why we have to create break lines where they are appropriate. And we'll see that as we go along. So you can imagine, well, right here is a very classic illustration of, if we did not declare this line that you see me tracing right here, what would be the flow line of the curb, if we did not say, before we hit the go button, if we did not say that that was a break line, then these triangles here, points that I've measured out here, say point B and point F, C and G, or even B and G for that matter, A and G, A and E, all of these triangles are free to form in that fashion if that's the way the algorithm actually creates them. We don't have a lot of control over how those triangles form, and sometimes it's just a first in first out kind of thing. If these things were created first, they may get evaluated first. We don't know. But what this is saying, when they form in this fashion, is that this triangle goes from point C to point G to point F back to C. And we're saying that all along this line from C to G, it has an increasing, a linear increasing elevation from C to G, just in a straight line. Well, we can tell by looking at this that obviously it doesn't. It goes nearly vertically up and then horizontally across, when we're looking at that in the real world. Same thing, A to E. It doesn't start here and go straight up to E. It comes down here and hits this line at the flow and then goes up nearly vertically to E. So, but, and in contrast, C to F or C to B, C to A to E, those are all valid, but these dashed lines are not. So if we do go in here and say this line, this flow line, and this top of curb, and this edge of pavement, and this back of curb, if we say those are break lines, then it keeps these triangles from forming, because what a break line does is basically say, hey, you can't create a triangle across this barrier. And you can think of it as saying, when you declare a break line, you're saying, hey, I'm building this wall, and that means anything on this side of the wall, any of these points, none of them can look across this wall and find points on the other side to connect to. Everything that point B can connect to has to be on this side of that line. Same thing, with this line. So that's just little local arbiters, if you will, of this data that forces the triangulation to lie in certain planes. And that is a pretty fundamental understanding that we need as we do our grading design in particular. A lot of these tools, for instance, pond designs and roadway design, a lot of those things are going to automatically get handled for us, but there's times when we need to create that kind of stuff manually, so it's good to understand that. All right. So as a means of understanding this process, please use these um, front upper sections of the manual to excuse me, uh, to get a really good understanding there. I would even recommend you maybe, put a bookmark here at this page 25, this exercise on adding brake lines. Um, and it shows you the difference. In fact, uh, maybe we'll run through that part really quick to show you how radically different that this can be if we don't interpret things correctly. All right. And we'll use that time to get familiar with the 3D viewer. Matt, are you very familiar with the tools like the Carlson 3D viewer and things like that? Or you're still pretty new to the Carlson side of things, right?
Yeah, I haven't really utilized it yet.
Okay, no problem. So we'll take a peek at what we're doing. Let me also ask too, both of you, by the way, are you using are any of you using excuse me, let me change that again. Are either of you using the IntelliCAD version of the software? The IntelliCAD CAD engine, or are you using the AutoCAD CAD engine?
Auto, AutoCAD.
Okay. Kaylee, what about you?
Mine says IntelliCAD.
Okay. All right. So now I will be teaching with the IntelliCAD version myself, simply because I find it more stable, actually, and and that's not because the Carlson side is different. It's not. Um, it's the CAD engine that's more stable. There's too many sensitivities on the AutoCAD side of things, and that's not to say that it's any worse. In fact, there's a lot of things that are some people like better with the AutoCAD side, but there are some other tools that we'll talk about on the IntelliCAD thing. The bottom line is, though, that the command, when you run a Carlson command, it doesn't matter which system you're running, it's going to present a dialog box or a series of prompts for you to set up the command. And it's going to gather all that, and then it's going to figure out what CAD commands it needs to run to do that task and send that to the underlying CAD engine in the background. So you're not going to have to be concerned with that. But there may be some slight differences in how you handle things like how to set up a text style, how to um, start a new file and choose a drawing template. So it hands it off to the underlying CAD system at that point and runs it. So it's not anything to be terribly concerned about. Um, but that's just keep that in mind, Matt, especially you, because I'll be running this from the IntelliCAD version of it um, as we go along. Um, and there's no particular rhyme or reason for that, other than people that I most of the students that I do teach, where a lot of them are on the surveyor side of the world, a lot of them are more budget conscious than a lot of other companies. And so, because the IntelliCAD side, the IntelliCAD part is free, um, that tends to be, a nice $1,500 to $2,000 a year extra bit of money that they don't have to lay out. So um, that just tends to be the predominance of the types of students that I teach. So that's why I use that version, and I just flat out enjoy it better. It's a little bit leaner, uh, in my opinion. Okay, so there is that. Now, one last thing I will tell you up here in the um, about your instructor bit, you can see a little bit about this. Although this It's 30 years. It's getting close to 40 years at this point. So, um, but here's the thing. Now, you all have some of my previous email, which has my phone number included in it as well as, but here's also this with my contact email. Please keep that handy because anytime after the class or anytime in the future as you come up, as you're going through things, you get stuck on something or want to know how to do something, please just send me an email or give me a call and ask me about that you'll always have access to us after the class. Okay, so and tech support, say with CARLSON, directly back to CARLSON, is free and pretty good. They're really quick to respond. But sometimes you'll get a more of a programmer's response and less of a practitioner's response. Whereas, I've been out here doing the things that you guys have had to do. I've had to prepare construction documents and get them submitted to the Department of Environmental Protection for approval. And I know how to generate plans and profiles and all of those different types of things. So feel free to get in touch with me. That's part of when you pay for this class, that's part of what you're paying for is you are buying that access, and that doesn't go away. And I will always be able to respond, with an answer, particularly if it's a simple, how do you do this? Well, here's how, a real quick email reply, bing, bang, boom, go on your way and about your business. If it gets into something that is like, and even if it's something that we haven't talked about in class, feel free. Matt, for instance, you said you do, drainage and piping and all that, and that really sort of gets into the hydro module, but you can do a lot of it still in civil. So, but please don't hesitate to ask. And if it gets into something that would take up a lot of time or that I think, well, you might be better suited to sort of, take a little more holistic approach to this or a little deeper dive, I'll let you know that. And if it would be something that takes, 4 or 5 days to accomplish, then we'll talk about, maybe engaging us as a consultant on a particular project. We'll always try to find a way that makes it, doable and financially makes sense for you in terms of what you're doing. But simple, questions or pointings in the right direction, please don't hesitate. They're there, and that's what you, like I said, what you get access to as part of this class. Okay, so keep that part in mind. Now, a couple of things that we will do is that we will go over from the fundamentals side. Let's see, this tells us a little bit about how the manual is structured. A little bit, we've talked about this already, about how it sort of takes data from us and builds the input into CAD commands behind the scenes, and that's basically what that's doing. But we need to talk about where things go and some of the settings that we need, or to at least understand how they apply and what we're doing. Okay. So when we talk about organizing your work, and I'm on printed page 4, physical page 10 of the PDF, there is a way of how these things are structured and how they're done. So you've got, if you look at, then it's talking about this bottom row and middle row and top row here. We're talking about this toolbar if you're using the ribbon, and that's the panel out of the toolbar. And you can also get to those things like this. So that would be under the setup tab if you're using the ribbons. Well, actually, no, that's probably on the file tab. This is just a static picture. I can't show you that. We'll look at that in a minute. But that's also available on the settings pull down menu under Carlson menus. And here you can see there's survey, civil, hydro. There's your surface mining menu, for instance, down there at the bottom, Kaylee, that you would have access to. So those are all how that part is structured. And what we'll do in class, I'm going to probably keep my ribbons turned off just because the resolution, I have to have the screen to be able to do the screen sharing. And with a couple of other toolbars that I keep out, it squashes down my usable graphics area fairly small. So I like to do away from those, but we'll show you what they are and how they work, and you can get a nice sense of how they work. And that might make better sense for you and your workflow and how you approach this. So I'll probably teach it predominantly from the menus. Some of these will figure out what toolbars maybe would be fairly efficient with their workflows, and we'll go from there as well. Okay. Now, the other thing to talk about is, like I said, we need to know where things are going to go in our directories that we set up. How do we store our data? And we have three options, three storage models, if you will. There's this project folder model. There's a drawing folder or a fixed folder. And the default out of the box condition is set up to be the drawing folder model. And all this is where these are the default locations of where the software starts looking for data, either to load or when you save something that you've created, where is it going to go? Where's its first choice? And so these are basically just setting default behaviors. You can always at any time override where this stuff goes manually, just like you would normally do it in a any Windows type situation. When you do something like a file save as, and it lets you navigate to other locations. Okay, so that's always doable. But the models that we have and some of their strengths are this project folder is you would set up, and you can see here in this little screen grab, a structure that when you declare a project, underneath that folder and that project, what you're looking at right here where it says the word project, that's going to be whatever yours is. Like it might be I-40 interchange, whatever you've named it. But then under that, you've got a series of folders that you create. And then once you create these folders, you assign the various Carlson data types to be placed in these various folders. Okay, so it's a good structured approach on storing these things where it might make sense. And you can see from the names of these where I've created these. Now, the other advantage, particularly for project managers, is you can make any folders you want. They don't have to be anything that Carlson uses. Like you can got a deliverables and you got PDFs and maybe you've got another folder that's called contracts, or emails or source information from other people, what have you. And you can create those, and if that makes for a nice workflow for you, then anytime you start a new project, it's going to automatically create those folders and start to use them. Okay, So that part's handy. It makes it uniform across larger organizations. If you're not such a large organization though, and if you don't necessarily want to have all of your data sort of spread across these files, this drawing folder bit that we're talking about in the middle, that basically says follow the drawing. Wherever your drawing file is, wherever your DWG file is, the first place I'm going to start looking for data files, whether to load them up or to save them, is going to be in that same folder. Okay, that's the simplest approach. And again, like I said, the default condition. This other one on the far right is there for legacy purposes, and it's a fixed folder location, and it's the way it used to be done way back in, I think when the software came out, it was like 1980. 3 or 4, I'm not sure when it exactly came out, and it was surveying software only, and they had a folder called SCAD data, which stood for ServCAD data, and that's where all the data files went, no matter which project you were working on. So you had to name your files with your project names and all of that. So it was a little bit odd, and it didn't let you change that location. So it put all the data all in one spot. So if you ever needed to get to your data, you knew exactly which folder to go into. The problem was it was a little bit tough to manage. So that evolved, but it's still there in case you want to use it. All right. So again, the default condition is that drawing folder model. And here's just a screen showing you where you can assign the different CARLSON file types into those different data folders that you created. And I'll show you a little trick when we get to that section that you can use if you're ever stuck on what it's looking for in terms of a file type. Okay. And then, so we're going to talk about like the different menus. There are general menus, and then there are the modular menus. Now, by that, I don't mean that the menus are modular and they're put together with building blocks or things. I just mean it's the menus that apply for the different CARLSON models or modules. So the general ones, and these are the ones that are shared by every module, whether it's civil, mining, survey, construction, it doesn't matter. But file, edit, view, draw, inquiry, settings, and points are going to be common across all of the modules, as well as the last two, window and help. And that comes out of the fact that it's running under Windows. Okay? So, and that tells you just briefly what those things do. The file menu has commands that would be related to working with the file itself. Now, there are some, like I said right here, some few hidden gems like drawing cleanup, microstation support, project management commands, and then the edit menu has a lot of edit tools that you imagine, like copy, erase, move, etc. Some are CARLSON modified, so what we call CARLSONifications, if you will. And so that's going to be where we do a lot of our work, as well as the draw menu. So if we don't have something in our drawing and we need it, we might look at the draw menu. But if it's there and we need to change it, we would look at the edit menu. Or if it's there and we want to find out stuff about it, we might look at the inquiry menu. And we do some specialized things like setting things up and then working with CARLSON points. Now, a word about that, and let me see here a second. My air conditioner just kicked in. Let me see if I can get the... All right, can you folks hear me okay still?
Yes.
Okay, all right, so I switched into my AirPods. I think that will filter more of that, the fan noise from my air conditioner. I apologize for that. All right. So let's see. Yeah, in terms of points, and we'll talk about a little bit about what they are and how they're useful, but they're not. It's not something that civils and mining folks typically use. It's more used in the surveying side of things. Um, but just in case you ever have them, you know what they are and how to work with them. You can certainly use them. There's no reason not to if you think in terms of points, but there's no particular reason that you have to as well because everything works off of drawn geometry. And for instance, if I were going to draw a, let's just say a somebody's property boundary, I I could start out just by say drawing a particular uh, line. I'll just start at some arbitrary point, click, and I'll go to another point, click. And then if I'm reading that deed, you know, and I would edit that, you know, I would set that line to be at a particular direction and in a particular distance. And then I would draw another line starting from the end point of the one I just drew. And I would set it to to its specific direction, you know, like north 37 degrees, 15 minutes, 26 seconds east, and then go a particular distance, whatever the deed uh, line called. Or if I knew I was creating a sidewalk along a road, I knew that I was going to be 4 feet off the back of curb. Well, I would offset the curb line 4 feet, and then if I knew it was a 6 foot wide sidewalk, I would offset that line 6 feet. So we as civils tend to predominantly uh, create the drawn geometry, whereas surveyors, if you tell them to go out there and draw 100-foot square, there are some surveyors that are so geared up to be point thinkers that they'll go out there and they'll drop a point and then they'll traverse their way and drop points, you know, set a point 100 feet due north and then sit on that point and backsight the previous point and turn an angle of 270 degrees to the right and set and go 100 feet and set another point, and then they'll get 4 points, and then they'll draw a line from point 1 to 2 to 3 to 4 and back to 1. Okay, nothing wrong with that. It just uh, not required, but it also behooves us to understand points if we get points in data that comes to us, say, from surveyors. And, um, you know, we can use those points to help refine what we, you know, how we build our models. They can also be, um, you know, you can get, there's a CAD entity called a point. And even in MicroStation, for instance, it's actually points are technically lines with zero length, which geometrically is what a point is. So they are specific things, and you'll see those when we take a peek at one of our example files that was compiled by an aerial mapping firm, and they were just spot elevations out on the ground, and we want to use those. But they're just, in that instance, they're just CAD points, and they're not CARLSON points. CARLSON points are specifically CAD points, but they're coupled with symbols and with a block that holds a point number, and it holds its elevation, and it holds a description. Okay, so because of that, that particular block that's coupled with it with those point numbers, it makes working with points sometimes more efficient. If I've got you know 150 points and I want to draw a line between the first point all the way through everything to the last point, well, all I need to do is say, you know, draw a line from 1-150 and hit enter, and it will do it for me, stopping at each point along the way, and I don't have to snap to those point locations and all of that. So there are times when it's to our advantage. So, but you probably won't use them a great deal. And but I do want to touch on that a little bit so you know what they do, what the tools are. Okay, so we'll spend a little bit of time with that. And here, skipping ahead to point 10, it talks about what these points are. Here's an example of points with symbols. Up here's the actual CAD point itself, and combined with a symbol and the block that holds the point number, the elevation, and the description. A setting here that this particular item is one of the settings things that you'll see. This only applied to the IntelliCAD version, and they have since fixed this particular error. It was something we had to take care of manually. So there's one place you can ignore, and a couple of exercises there. We'll see how they work. Okay. But then what I want to really go over, and I promise I won't do it in such depth that it just bores you out of your skull, but we do want to talk about settings and what these configuration items are going to do for us. And we'll see that in a minute. And it just talks about settings in the book on one page. Shows you 2 ways to get to them. But what you'll see as we go into there, they're really depth. There's really a lot of depth in those and how they control what we're doing. Okay, so we'll take a look at that as well. All right, now, all of that being said, finally, and I'm sure you've already done so, but if you haven't, go ahead and load up CARLSON and we'll start the process. Everybody can see my screen okay? It says CARLSON.
Yes.
It carried up, okay,
Yep.
because I switched operating systems. I just want to make sure
Will it matter if I have 2020 and not 2021?
No, not at all. It might matter if you had 2014, but yeah, 2020 should be fine. Now this is, again, this is the start page, which is very similar to AutoCAD's in the sense that you've got recent documents. You can open, browse for files, or go to a new drawing. So I'm going to just go to a new drawing. By the way, if you use this, you see these, there's a couple of things that a lot of people overlook. There are pins over here where you can pin something to this recent menu. You've got 2 icons down here at the bottom. Whereas if you don't want to see the previews and you just want to see more of the file names and dates, you can do that. And it also shows you the sizes over here. But you've got, some support options over here. If you click that, it goes right straight into the CARLSON support. CARLSON Academy, that's sort of the training kind of thing. I don't have any idea. I even wants me to log in. Let's see what it does. Manage accounts. I don't know. I guess you can set up a series of training sessions through that. The knowledge base, which is again, things that people have come across from a user standpoint. You can send feedback. You can skip this start page next time if you choose to, right, by clicking that. Over on the right-hand side are some news items. That's sort of the news feed that you can jump to. And here is one very interesting kind of approach, is that you can use a drawings map. Now, you can have a drawing. I'm looking for a particular file, and it's really, when I hit that drawings map, it just goes to open drawing. so I can navigate to a folder and find a drawing. Or if I choose map, it's going to actually load up areas where I have projects. And I don't actually have a project in Mexico, but you see, it's called test.dwg, and it's probably got, coordinates of like 5,000, 5,000. So that's why it's showing up over there, because it's trying to, uh, put this thing on. So if I wanted to say, and if I search for Pittsburgh, all right, so that jumps into that area there. I've got a project here, which is some, uh, that is a drawing, a construction project that, we did South Hill Square. So that will help you, locate those by a particular feature, in this case, on the start page with this drawings map. To be honest with you, I haven't really found it to be incredibly productivity enhancing, because usually when you're working on a project, you know where it is. All right, so, but it's there in case you ever need to see, or if you're in a larger organization that might have a bunch of files that maybe you didn't work on, but they're on the server, and you may say, well, I think I remember a job we did, 2 years ago that shared this same property line. Not sure what it was. So you can, use that to some advantage. Okay. All right. So let's just go to the new drawing, and you'll see that, at least in the IntelliCAD version, they're going to have, you can actually create and work in a DGN file directly, which is a microstation file. You will most likely, unless you're working on transportation projects within your firm that's using multiple platforms, you'll probably be most of the time in the DWG world. That's an AutoCAD file. And I'm going to use a template drawing. So I'm going to say next, and here's where I can select a template. That's my default template called CARLSON National CAD Standards. I've got all of these different ones that are pre-built for me. There's also CARLSON National CAD Standards Survey Civil, so it's designed for Survey Civil, whereas the one that I'm using probably also has architectural and maybe general. I'm not sure what else is in there. But anyway, and Kaylee, in particular for you, to understand what these drawing templates are basically drawings, little small, mostly empty drawings that we have set up ahead of time that have a series of settings already taken care of for us. Like, we've created all of the layers that we think we're going to need, and we've set them to particular colors and line styles and line weights. Perhaps even we have set up particular title blocks in what's called paper space, the place where we do our layouts to generate our drawings, where we've created our own, company defaults. We may have also defined certain blocks, like we may have a whole series of blocks that are special symbols that represent certain structures or points or any kind of things. So we pre-build all that stuff and we save it in a drawing template, and then we use that template to start with. It's much like starting with a drawing that we're satisfied with, because we liked the way everything was set up, and then we did a save as, and we gave it the new name of our new project. It's sort of like that, but lets us do that ahead of time. Okay, so it really, for this example, it doesn't matter at all what you start with if you're using one, but I'll show you the example of when this happens. Because when you normally start up the layers and such like that, you only have I think, 2 layers. You have layer 0 always, and you'll have a layer called def points, DEF POINTS, and that's a non-printing layer that holds definition points for dimensions and such like that. We'll show you those in a minute. It's nothing to really worry about keeping track of. All right, so if you're using this out of the box as it is, you're going to probably encounter this startup drawing wizard. Do either of you not have this on your screen now? Or maybe you went past it, but I did. Did either of you not see this wizard come up?
No, I saw it.
Okay. All right. So notice down at the bottom, there's this little skip startup wizard next time. So if you don't like to use it, you can do that. But if you do, there's only one place that I'm aware of that you can turn that back on, and I'll show you where that is. Because I tend to find this very useful to get things started. So this is starting up a new drawing, and we're going to set some settings here to get us underway. We're going to say, first of all, I'm going to work in an English system. 1 inch equals whatever number of feet. You could have the option for metric, of course. And I'm going to set that scale. So 1 inch equals, it says question mark feet. So I'm going to say 1 inch equals 50 feet. Now, to understand this, first of all, when we draw things in this file, we are not, let's say if I have to draw a 300-foot long line, okay? Because I'm saying 1 inch equals 50 feet, I'm not going to draw a line that's 6 inches long. I'm still going to draw a line that's 300 units long, 300 feet. Feet are my units. And, but when I go to plot my drawings or print them, and when I create text to label my drawing, it's going to generate things in relation to this declared scale, where it's going to expect to go on a piece of paper where that 300-foot long line will be 6 inches long, because I'm drawing this at 1 inch equals 50 feet. Okay? So that's all in the world this is used to do, is to set the size of other things in relationship to this, one of which is a symbol plot size. And I usually like to keep that set up to be 1/10 of an inch. So you see there, it's 0.0, or it's 0.1. And like I said, you want to keep that, you want to think of that when you see plot size, when you see that term, symbol plot size and text plot size, think of inches on the paper at whatever scale you have. Okay. And my default text, I'm going to set a little bit smaller than 1/10 of an inch to 800, so it's 0.08. Now, here's what it does. It creates, if I say I want this to be, well, let's say if I wanted 1/4 inch tall symbols, if I go over here and type 0.25, now watch what happens when I tab out of that field. This number is going to recalculate itself. Okay, that's the number 12.5 that CARLSON commands send to the CAD engine underneath it as to what size to create symbols or text. We don't have to do the math anymore. All we need to do is say, well, I want my symbols or my text or whatever to be, in this case, 1/10 of an inch. And then if I change this from 1 inch equals 50 feet, let's make that 1 inch equals 30 feet. If I tab out of that, you see these recalculate. These numbers didn't change. So I still say I want 1/10 of an inch symbols and I want 800ths of an inch text. And based on whatever this number is, it creates them at these heights. Okay. And then once they're created, unless they're annotative, we'll talk about that a little bit later, they will stay at that size. And if I need them to change, I've got other commands where I can rescale or resize those different drawn objects. Okay. So that's all you need to remember is if you're in English, you're going to set the anticipated scale, and you can change this. This doesn't lock you into something. You can change it later on if you need to. And you're going to set the symbol and text sizes based in terms of plotted inches if you're in English, or if you're in metric, you want to think in terms of plotted centimeters. Okay. And you'll see that word plot size, there's your key. You'll also see scalar, S-C-A-L-E-R, as opposed to scalar AR, which is like a vector with a directionless vector. But a scalar ER means that it's using the scale to create the size. You'll see that sometimes. You'll see symbol size scalar or text size scalar. So plot size or size scalar, think plotted inches. Okay. Now, this next bit here is pretty important. Is if you are working on projects that have been based on a survey where the surveyors are giving you survey data that are, typically in a state plane situation, or you're trying to match existing data from somewhere else, maybe from an internet download site that's in Universal Transverse Mercator or different, coordinate system projections. So if you say state plane, let's go ahead and put it as NAD 83. That's why you've got 1983, 1927. So we'll use the 83 datum. And then our zone. Now for me, I'm going to scroll down and find PA South. Okay. And then my latitude and longitude datum is either my World Geodetic System of 1984 or it's NAD 83 or NAD 87, depending on which one of these things that I'm using. So I'll keep it as WGS 84. Oops, and I guess it reset that. State plane, PA South, WGS 84. Okay. Now, why this is important is there are other commands within the software that allow you to do things like load up a Google Earth map. For instance, if you have Google Earth installed, it will go out and run Google Earth and find you that map, and it'll bring it in and load it right into your drawing at the right coordinates, all right, based on where those are. When you tell it, hey, I'm in NAD 83, or if I'm in NAD 27, or if I'm in whatever these different, and by the way, Kaylee, and maybe even you as well, Matt, I say NAD, that's NAD, that stands for North American Datum. That's a horizontal datum. And there's also the either NVGD, which stands for the National Vertical Geodetic Datum, that talks about the vertical, elevation component of this system. Or there's NA, instead of NAD, there's NAVD, or the North American Vertical Datum. So those are, and it's of 1929 and of 1988, as opposed to 1927 and 1983. And those are getting ready to change here pretty significantly in the next couple of years. In fact, we are going from what's called the U.S. Survey Foot. We're going to be using the International Foot definition in terms of all of our geodetic referencing. Nothing you need to worry about, particularly for today's class, but those things change, they evolve, and you'll have, you know, some people that will help you know when and where to use which ones. All right. Ask your surveyors if that becomes an issue. All right, so as we can see now, we're going to hit the next button. Now, there will be an error that comes up, but I'm doing this to let you see how this is handled. When I say next, it tells me, missing the drawing name. I say, oh, yeah, duh. I never once set the drawing because, and this is where it's real easy to skip past. Up here it says new drawing, and there was nothing out here. All I did was say I wanted to make a new drawing, but I didn't save the name. So I need to save the name. So I'm going to come, it's not going to let me past it. So I'm going to come up here and hit this set button. And here comes my dialog box. Now, a lot of people will take this and they'll immediately go to this browse button because that puts them in familiar territory. This is the Windows dialog box where you've got this file of type that you can pull down and you can navigate your way around. And that's fine. There's not a thing wrong with that. However, the CARLSON dialogues, once you get used to them, are pretty handy as well. And here's a couple of things to point out. Up here in the top stripe, you will see in parentheses a series of letters, which are the acceptable file extensions that you could look for. So if we're looking for, say, you know, text files, you may see txt, comma, asc, comma, csi, comma, all of these different typical types of things which correspond to, in our browse, pull down, save as type. In this case, there's just the one option. Okay, so we could get a sense of what those allowable extensions are. Okay, and if you don't provide, if you just type a name and don't provide an extension, it will supply that for you. Okay, and if there are multiple extensions, it will use the first one that it sees there. But if you want to, let's say we're talking about an image file and it's looking for a JPEG, a JPG, or a PNG, or a BIT, or a GIF, and if you want to not save that as a JPEG, but you want to save it as a portable network graphics file, all you do is type the name .png. You provide the extension. It takes care of creating that format. Okay, so that's a couple of ways to use this. So it tells me up here what folder I'm in, and if I click that field, that's a pull down that shows me basically where I've been. I've been dropping breadcrumbs. So here's the last time I ran this particular module was back in May, the 5th of May, or the 12th of May in 2021, civil class for there. So I would maybe go back to there and you see I've got a completely different set of files. So that keeps track, that's sort of your file history. And it's, you know, as you go along, that of course changes and updates itself. You can just type a name. If you hit browse again, you go to the Windows browser, which again you can do. But over here on the right hand side, there's a list of subfolders that are in the whatever folder I'm sitting in. Right now I'm in CARLSON Projects. I see these folders in it. If I switch to one of these others, I see that that folder did not have any subfolders. And these buttons, of course, I can step up a folder. You know, it's very similar to the way you would navigate within Windows. Okay, so you can also select with a search. You can pin one and set it as your default data. Set one as a favorite. Let's see, you can rename, delete, create. But here is what I was getting to, is that you have a list of these folders, or a list of the files that are in whatever folder you're in up here. And then down below you have recent files of that type that you've been using. So even if you've stored things off in a whole bunch of different folders, instead of having to come up here and pull this down and switch and go back and forth, you can simply go down here and select it out of the recent list, and it will have that right, or the correct file that you're looking for. Okay, so, and the last bit, which you don't see it in this instance, but you'll see it again later, is that some files will have a visual preview. Coordinate files will show you a little bit of the start of the coordinates with the point numbers, the northing, easting, and description, so you can see if you're in the right file. Surfaces, you'll see a little drawn picture of the surface. Alignments, you'll see the drawn horizontal alignment. Profiles, you'll see what the profile looks like, so that it helps you do some visual confirmation before you get to it. All right. So now, with that said, let's go back up here to our folder, and we're in Carlson Projects by default, or I am. If you need, when you browse that down, I'm going to put this in my class folder here. I've got 2021-07-28 civil class. I made that folder today, downloaded my data into it. Here's my data sets for civil class. So I'll go down inside of that as well. Okay, so I'm in that folder, data sets for civil class. No particular, I mean, I do have some files in here. I don't want to choose any of those because it will overwrite those files. Now here's something to do. Either of you see, and I'm not sure what you might have, do either of you see those files that start with a period and an underscore? Either one of you?
Like in the dataset file you sent?
Yeah, in this, wherever you've, I'm looking in the data set that we downloaded from that email link that I gave you. I'm just wondering, is your system set to show you those files that start with a dot and an underscore?
Mine doesn't show them there.
Mine doesn't either.
Okay, as you say, if you happen to see those, and anytime in the future, if you're back to working with the data set that I sent you, you may see those, and those are hidden files, and you see they're all of the same size, just 4K. And what those are called resource forks, and that's because they were created on a Macintosh. You can simply ignore them, or you can even delete them. They're not going to hurt anything to be there. But you know, you could, if you do see them, just ignore them. They're not going to have any meaningful data in a Windows system. And then, of course, if we were to pick one of these, it would overwrite what we're trying to do. So I'm going to just make sure I'm in the right folder, which I am, data sets for civil. And then I'm going to highlight where it says file name, and I'm just going to call this class example 1. I'm not going to put a .dwg extension on it. It does it for me. And now I can see up here in my wizard in this top line that I do indeed have that file name. It's been set. I've got my scale set to 30 scale. I'm in State Plane 83, Pennsylvania South. And by the way, don't worry about matching that right now. We're not going to have any state plane coordinates to deal with here yet. But it's always good if you are on state plane with your data to make sure you figure out, you know, what that is, or find out what that is and use it. So I'm going to now, yes, go ahead.
Why is state plane 83? Why don't we match that with the NAD 83?
Right here, you mean?
Mm-hmm.
Okay, because the lat-lon, or latitude longitude datum, and by the way, too, here's something else I wanted to point out and didn't earlier. You see this label, lat-long datum, and it looks like it's right beside this PA north, south, whatever that pull down was. That's simply because of the size of the dialog box and the resolution of the screen. The actual answer to that question is always to the right of it. So there's a bigger gap here than there is here, whereas stylistically, these words should be over here on the right. Okay, but they're not done that way. And that's just a nature of the way the dialogues present themselves. So anytime you see, you might see something that looks like it goes together, particularly with their pull downs, or if they're fields that have answers in them, the question to the answer is almost universally to the left. So keep that part in mind. Now, the reason you don't have this, and in our case, it wouldn't matter, and sometimes that is the case, but there's a very subtle difference in the origin or the datum for the latitude and longitude computation for this particular geodetic model. In terms of our use here doesn't generally matter, but the GPS systems that will store surveyed points and such are going to be recording data and computing coordinate positions based on one of these datums. This is basically says, where do I start the 0, 0? And in the case of the North American datum of 1983, which is really a horizontal distance on a flat grid system, that's why up there where it says projection, state plane 83. But we're saying use the starting point of that same system as the defining point of the latitude and longitude. But now, latitude and longitude is not a linear series of units. They are degrees around a geoid or an ellipsoid, and their origin is at the center of the earth, essentially. Okay, so but there's a very slight difference. One of them is based on North America. That's the North American datum of 1983. So there are some adjustment factors on where it calls the center of the earth. The WGS 84 was a system developed and adjusted the following year called the World Geodetic System that is a little better in terms of modeling the exact center of the earth that fits locations all around the globe, over in Africa, in Asia, up in Russia, in England, wherever you happen to be. If you use that same starting point, your latitudes and longitudes will tend to match up. So, and again, they're very close to the same answer, but most of the US GPS satellite systems use that WGS 84. It's just a little more refined, if you will, than the NAD 83. But prior to that happening, that was the only datum we had. Now, the NAD 27, for instance, the NAD 27 is a system that, and again, is defining a horizontal flat sheet plane, and its 0, 0 origin is on a place called Meads Ranch, which is actually out where you are in Kansas, Kaylee. So that was sort of the center of the lower 48 of the conterminous states in the United States, and so that was its historic definition. But then we went from defining that, and they took that point up on the surface of the earth, and through a series of transformations, it calculated what would be the latitude and longitude of that point. So that became its starting point. But then when we started defining our latitude and longitude data from the center of the Earth, and that doesn't mean that we started the latitudes and longitudes, they're still always from the center of the Earth, but we defined it first from the surface of the ground with NAD 27. So everything we did, we started with that surface measurement, we converted it to a measurement that got us to the center of the Earth, and then we came back out to whatever projection we're in. All right, so that's the long, convoluted answer to why wouldn't it match, and you would think it does. And then in the case of using state plane 83 and NAD 83 as an origin, then it really wouldn't make enough difference that we would see it in the numbers if we were to use NAD 83 instead of WGS. So it's just to match the data that we're expecting from GPS observations. And so that would typically be that.
Thank you.
Okay, so now if I did like NAD 87, you could still have those as the definitions, but you could probably at that point switch to wherever the data that you're using. Let's say if I'm working on a project, my surveyors tied into some old survey control points that were set way back in say the Depression years. They may have been defined based on this NAD 27. So that's what I would do, is set that to whatever was the basis of definition of the data that I'm expecting. Okay. All right, so we just set this back. And again, the reason I'm setting it up here is just because, just by example, this again is not going to have any bearing on what we're doing. But, and in fact, you can leave it as none if you're working in an arbitrary system, just 5,000, 5,000 as your starting point. Otherwise, your coordinates are going to be in the millions instead of the thousands. So if you're in an arbitrary system, I would set that to none. But if you are working with data that has been set to state plane, it's best to match that. So when things come in, they're going to line up over top of each other in the right position. Okay. So let's go ahead and hit the next button. And now you can see, based on where we have told it things are going to go, it says, okay, well, based on where you showed me, I'm going to think of my data path as being, because remember, I'm now in a follow the drawing kind of model. So my data path is wherever I stored that drawing, which is in data sets for civil class. I can again navigate to a different place. Next is a coordinate file, a CRD file. And at this point, you have to assign a coordinate file, okay? But you don't have to use it. You don't have to have anything with it. And if you open an existing drawing file, something that's already been created, it would not necessarily have a corresponding coordinate file with it. Let's say you got it in from an architect or something, then when you open a file, you don't go through this. You don't set the coordinate file. But this is what the wizard does, is it helps to create these files that that it anticipates you might be needing. So we saved our drawing file as class example 1. So it's going to offer to create this coordinate file as class example 1.crd. Now notice that the next lines down say coordinate file new or existing. So if we keep it on new, that's fine. And as long as this didn't exist, that would also be fine. But let's say we did have one that was the same as an existing file. I'm going to you don't have to do this, but I'm going to hit the set button. And I'm going to go ahead, I'm going to find this one called roadway 01. Okay, so see what it says? It tells me that that already exists. Do you want to replace it? All right, so I'm going to say no, because if this should happen to be the same name as one of those files, then it would write, it would create a empty one over top of the one I was trying to use. So, and if I said existing, then that would let me find that file. And then I guess the only thing, if I do this, and now if I choose that, all right, but so I've set that, and if I were to say new here, notice I don't get a warning now. I've pointed it to that one, but I say new, and in this case, once I go past this, it's going to write over top of that file. So be careful with that part, okay? So for now, I'm going to say set, and I'm going to go back to that class. And it does not have, it doesn't have to match the file name. By the way, look up here at the top, stripe, the CRD, CRDB, CGC, MDB, and ZAK. Those are all the different types of files that can be used for coordinate files. All right. Okay, I guess I click down on the class example one. So there we go. Go back to that. And then part of this can bring in points from these other sources, either a data collector from the surveyors, or a text or ASCII file, or from, not, this is not named, in my opinion, all that clearly. Current CRD file. Well, the current CRD file is the one I'm just getting ready to create, to my way of thinking. What that should say is existing CRD file. It should be some other existing file. That's what they mean, a currently existing CRD file. But some surveyor on a committee somewhere, or not surveyor, some programmer on a committee somewhere got away with leaving it set to that. But just so you're aware, that's what that means. It doesn't mean your file. It means one that currently exists, or no import. So we'll just leave it at none. I will say next, and it's going to come in and create everything that was in the drawing, or the template drawing, as well as all of the settings that we just went through in terms of that drawing wizard. And so let's look at the view menu and look at our layer control, for instance. And you may see, depending on which drawing template that you used, you'll see a list of different layer names and colors and line types, whether they're on or off, locked, frozen, line weights, etc. So I've got all of these C dash layers. Those are my civil. I should have some V dash. I guess I don't. V dash would be survey. And the reason they're not S dash is because the structural engineers got in line first. And then here's my G dash, which are my general. And you might see A dash, which would be architectural. And they can be anything you want. But see, I did not have to go through and create all of these because I used my drawing template and it was pre-built for me. But at some point, somebody sat down and made all this stuff. Right? Same thing as line types. If I click over here on the left-hand side, and this is one of the reasons, Matt, that I like the IntelliCAD version, is because in AutoCAD, all you can do is look at the layers. Now you have a different command. You've got a DC command, or a design center command, that does a similar thing to this, where it lets you take blocks and different things from one drawing into the other. But see, I can do the same thing here. I can go to this that's the drawing here that's still open back there, that first one that I opened called layers, and you can see the names are completely different on these layers versus these layers here. So if I needed, a couple of these layers like this, I could select them in one drawing and drag them and drop them onto the same category. In this case, it's layers. And now I go over to here and I look for that layer. There they are, those C-layers. Okay. And it's not just layers. It could be text styles. So if I've got a text style here's one that I'm using, point text with Calibri Light, and I don't have it over here. So if I take that and drag that and drop it here, so that's now in my definitions as well. I've got views, layouts. So if I've got a layout, and that's this paper space. So if I've got one that's using like, maybe I've got one defined. Well, here's one, plan, report, or here's two actually. So if I did plan and report from areas, and if I put them into my drawing, I'll show you what a great time savings this is. And again, XREFs, there's my external references, material definitions, defined groups, dimension styles, text styles, blocks. Here are the different blocks that are defined in one versus the other. If I want to transfer them, I just go from one and drag and drop into the other as well. Okay, so that's what our drawing template does, is it pre-builds those things for us. And now because I moved from this file, this areas file, I had this plan layout and this report layout, which is basically just a page definition. I brought them over into my drawing. So there's my plan and my report. And again, there's that like 8.5 by 11 sheet of paper. And this is probably a D or E size plotted sheet of paper. So it doesn't bring the data over, it just brings the definitions over. So that's one of the things that I like about that. I'm going to go ahead and choose this areas and close it. And so I just did that from the tab. Okay. So that's a bit about getting things started. And we're going to talk about some settings here in a little bit. But it's about 25 minutes, 27, 28 minutes past our mid-morning break. So let's take a mid-morning break. Let you stretch your legs, get some coffee, answer some phone calls. But let's be back here where we start at, say, 11:10. Okay, so 10 minutes after 11, we'll start back up. And then we will talk about some settings, and that should take us into lunchtime, and then we'll start working with some examples and hitting the actual command structure next, so you can have a little bit more fun than this mind-numbing crap on the settings. But I do want you to understand them so that it helps going forward. Okay. Any questions?
No.
Everybody clear? Okay. So I am going to pause the recording. I'll stop the share. And I will remember to share the screen. There we go. Everybody should be able to see that now. And let's go back to some settings here. Now, these are some settings, and I'm going to show you what effect they have so you get a chance to see what some of them do. But we're going to talk about them as well. Now, I'm not going to take the time to go through this stuff in a whole lot of depth. I'm just going to show you what you should probably set things to, but I do want you to see a couple of things and how they are different and how they apply, how they can affect what you are working on. All right, so If we go to the settings menu and choose CARLSON configure, and you will see a little control come up that has a bunch of buttons that are different categories of settings that you can set. And you notice at the bottom, there's also a load and save as. You will see those buttons on the bottom of a lot of dialog boxes. And sometimes you'll even go into a dialog box that has load and save at the bottom of it. And then you'll click on a particular button inside that dialog box that will allow you to also do a load and save inside of that. What those are just ways to save off certain settings. For instance, if you're doing work for a particular client or an agency that has certain requirements, remember all of those layers that you saw when we started this drawing file up. You know, maybe I've got a layer called C for civil dash CTRL for centerline dash TEXT, meaning that I'm going to use that layer called civil centerline text to store things like my stationing and ticks for my centerlines. And that might be fine for general use, but maybe I'm also doing work on a PennDOT project, and PennDOT says, okay, we want you to put your stationing on a layer called CL-STA-TXT, whatever, just so that we match their system. So that gives me a chance to load and save. All I have to do is, if I'm switching to a different client, for instance, I would load up their settings and it would overwrite whatever I had currently set. And, you know, different text styles, different sizes, different approaches, different things shown, different layers, different lines, styles, weights, etc. So that's true everywhere. If you hit the Save As button at this level, I'm going to go ahead and do that and show you. I'm just going to call it, say I'm in CARLSON Projects Settings 2021. That's where I've told it I want my settings to go. And I'm going to call this one Settings Global. And it saved 68,861 settings. Okay. If I go out and look at that file, you would see it's a text file. It has every one of those 68,000 some odd settings in it. So that's a nice way to, if you were trying to get a company to be on the same page with all of this stuff, then you would create those settings, save them out on the network drive somewhere, and then have everybody else just load those settings up so that everything matches. Okay, so keep that part in mind. Now, a couple of things here. I've got a localization settings. I've got things for takeoff and SiteNet. SiteNet is something that the civil module uses. We probably won't get into it much beyond an introductory level look at it. But if we, let's jump into there and see. Yeah, you know what? At this point, just ignore that and close back. If you opened it up, you can safely just close it. It doesn't matter what it says. I don't want to confuse you too much right now. All right, so mining settings, for instance. Now, Kaylee, you might have some things here that would apply in setting up your gridding for the surface generation. And drill holes and StrataCalcs, if you're using those external files, you can create those up. Setting up your key material, in this case it's by default set to coal. Yours would probably be set to limestone or whatever it is that you are harvesting out there in Kansas. Overburden, the partings, and these are just the suffixes that go on the named beds of those particular, at whatever seam, whatever material. These would be the suffixes that go on the name of that, and that you would see those various files with those as suffixes on the file names itself. Okay. Not going to deal a whole lot with that as well, the mine notes. So, that will be a little bit more specialized on your side later on. Hydrology, same thing, section and profile settings. There's not really a lot here other than some eye height and object height as it computes stopping sight distances for your K values on your curves and such, on your vertical curves. So it lets you set those here. And this vertical curve drawing resolution, I'll just leave it at the default. That's, because when it draws a vertical curve, Kayla, you may or may not be aware of that in terms of the civil roadway. Vertical curves are at least typically defined mathematically as parabolas. There are some instances coming about where they're starting to use actual circular curves for vertical curve geometry. I'm not sure how I necessarily feel about that. I think it interferes with ride comfort and safety a little bit. That's why we use parabolas. But anyway, it's an argument for another day. But in any case, if you'll take that as, I guess, just keep the default. And what it means is this drawing resolution is that when it draws a parabola, when it draws a, when it draws a profile, a CAD system can't really create a parabola like it can a circle or a line. And for a long time, they weren't even able to create ellipses. They've since added to that. But so now when it draws a parabola, what it has to do is it starts off drawing wherever that starts. And it goes and it looks at the equation that defines the parabola. And then it goes to a certain spot and figures out, okay, where am I supposed to be on the screen now to put the next little bit of this parabola down? And it does that, point to point to point to point to point, all the way down around the line. So if I plot a profile, it's going to actually be a polyline with a whole bunch of little interconnected line segments. So there'll be a whole bunch of little vertices or vertex points along that drawn parabola. And that's just a number here that tells it, how many of those little segments, how fine a resolution do I want to use? I don't have any idea what that 10 stands for. Is it 10 drawing units per, I don't know, or is it 10 little segments per what would be a plotted 1 inch? I just don't know what that number is, but you can tell if they're too coarse, you would make that a little bigger, and if it's slowing things down because there's too many vertices, then you would make that a little less. Okay. Now, crest and sag sight distance formula are actually different, but you could tell it that for sag curves, I still want to use the crest sight distance formula. Simply check that on. Okay, we typically don't. And the parabolic template grade subdivisions, again, how finely do I want to define my template grades? And this parabolic doesn't apply to the vertical curve, but this is talking about the cross-section shape of the roadway. Like here I've got a 4-inch thick layer of stone that is typically at a given slope from the center of the road out to the edges. We typically slope it down. Traditionally, that's usually been at 2%, which is just under 2.08%, which is the typical 1/4 inch per foot minimum for water to drain off a roof, for instance. So, but what this parabola is talking about is if the roadway, instead of being drawn like, stick right there, I'll be right back too. I just want to show you. So instead of being drawn like this, which would, if I can, this. Right, there we go. So like that might be the normal shape of a roadway from the center line, and it slopes off to the edge. They're saying it will create, instead of this being a straight line, it would be defined as a parabola that would look, you know, more like this. And I'm sort of cheating here. I just want to show you. Those are arcs instead of parabolas, but that would be defined as a parabolic equation. And now I've not run into any jurisdictions that use that, but apparently some do, because it's sitting there available for it. Let's see, where in the section of profile. So that means how often, when you create this as a roadway template in this cross section, if you're using parabolic subgrades, how many times do you want to, you know, slice this and define it along that parabola? And if you were to say, for instance, only 2, then it would be out here at the end and out here at this end. So it would be exactly the same as if it were just this straight line section. If we were to say 10 or 12 or whatever it is, then it goes from here to here and then divides it evenly into that number of pieces and generates that part of that geometry. All right. So that's what that means. Nothing to even bother remembering. We don't typically use it, but that's where it is. Now the station type. With English units, we typically use the 1+00 type of stationing, meaning 100 feet. Metric would typically be 1+000, meaning that many meters, or not actually meters, but the kilometers down to the meter, and then the 0.000 for the down to the millimeter part. If you don't, but the plus values, some places don't use those. They just go into just plain old distance values. And some actually put this NO like a number. So it would be like station number 1, number 2, number 3, but it's every 100 feet, every 1,000 meters, every what have you. So just as a means of preference. I've never, and I've worked, let's see, I've worked, started out in Houston, Texas, and worked on highway projects in Texas, Oklahoma, Louisiana, Arkansas, and then all the way back the Midwest and the Mid-Atlantic, all up and down the East Coast. I've never seen anything other than this one used, but that's not to say that there are places that don't. Some of these might be used in Europe, some in some very specific states, like I think Iowa has some sort of weird things, Wisconsin maybe as well. Um, anyway, it just gives you some options. Again, generally, the defaults are just fine as they are, so I leave those as they are. Now, the surface settings, I'll pop this up, and I'm not going to talk much about this, but the search radius, the quadrants, the min max, and samples, this has to do if you are modeling your surfaces as grids. Okay, so we're not going to be doing that. We're going to be doing triangulation. The number of cells in X and Y versus the dimensions of a cell, however you want to create that. So we're not going to do those. We will, however, look at these down here. Talks about simplifying a difference 10 to reduce size. Now, a difference 10, that's a triangulated irregular network. That is actually a measurement of the differences between two surfaces. In terms of civil engineering, that's the amount of cut and fill, for instance. So negative numbers might be represented as cut, and fill might be represented as positive numbers, whereas and we can draw contour lines for those surfaces, which is an amount of difference. There's no real need to simplify those. But there's also no particular harm in doing it either, because it's not really something that we're going to build. It's usually something that we're going to display. The building of a surface would be where we define a surface by a series of triangles, and then we put that on a a grader or a bulldozer or an excavator, and we let it be guided by satellite GPS information to do its automated machine guidance. Okay. We do, however, want to track our tin history so we can make changes and go back to previous states if we have edited our tins. And we might as well turn on include detailed source data. Depends on where our data sources come from. If we have, say, an XML file from somebody else, maybe in Civil 3D, has created a surface, we can get that file and load it into CARLSON and use it, and then track surface data changes. I'm admittedly, I don't really understand the difference between these two items here, because to track the tin history, you have to track the data changes. And if you're tracking the data changes, well, then you're tracking the history. So I don't really understand the distinction between those two, but I'll have them both on. Okay. The bit right up above here, draw the contours maximum number, or when you draw contours, what the maximum number of rechecks to check for crossing contour lines. And you can set that up to whatever it needs to be. Default of 10 is sufficiently fine. I've never run into an issue with any of that. Okay. Now, the ones that we're considering, if you look at the survey settings, for instance, the only one that I really want you to talk about or to be aware of is when you look across your menus at the top of your command set here. If you have the survey module, I'm guessing that not either one of you do, but if you did, there is this CG survey menu, either none, compact, or expanded, and that's a means into, if I go to compact, for instance, the see, this CG survey is now a menu, but I am in the survey module. It switched me into that survey module. I can tell because after the points menu, remember these are the general menus, file through points, then it starts into the modular menus and there's survey. And I now have this CG survey, which I've got file, traverse, Kogo, draw, management, tools, etc., or I can go into full mode. Now what that is CG survey was a very popular surveying system that was used by a lot of surveyors in this country back in the late 80s and going forward. So Carlson, however, bought them out back in the mid 90s, I think, or maybe late 90s. So, and they did so just to get to the least squares adjustments routines that they had for their survey observations. And in so doing, they incorporated the entire C&G command set into a little accessible menu so people that used it could still go back and do everything the way they always had. That's all that is. And if you're not using that and you do use survey, I would turn it off just to save that little bit of space. Okay, so now the startup settings. And I got to that by, again, I'm in CARLSON configure. It's on the settings menu, CARLSON configure. And I am in this button right here, second down in the right-hand column, the startup settings. These are what happens when it starts up, or where things are going to happen when it starts up. So there's my template name. So that's going to be a particular one that I'm going to use by default. I'm going to use the CARLSON National CAD Standards Civil. That's why I didn't have any survey stuff. I just had that civil stuff. You can browse and go out and find one that you're using for your company. And the CARLSON 2021 project folder default. So this is where it starts to look for projects, okay? If I were using that project model of storing my data. A profile name, this is the configuration of the CAD system, and it stores a series of profile names. I'll show you that in a second, but it's nothing you need to worry about. Your CAD managers will take care of that for you. And then the IntelliCAD switches for when it's running IntelliCAD. And this says don't put the logo up. Don't put the IntelliCAD logo up when you start. That's fine. And if you don't like the CARLSON splash screen, you could skip it with this checkbox here as well. Okay. Now, I'll say okay to that. I'll say okay to that. Go ahead and leave yours up. I'll just show you where the profiles that we were talking about there are. And that's under our IntelliCAD settings or AutoCAD settings. And you'll see profiles like, here's what happens. And this was created when it was installed. And this is called CARLSON 2021. I could have a different one. I can import and export different profiles. And all in the world this is a not a CARLSON set of settings, but the CAD system set of settings. Which toolbars do I have out? Where are my palettes anchored on the sides? What menu system do I have loaded? What visual modeling style am I in right now? I'm in 2D wireframe, but I could be using these different 3D modeling kind of things. So, what settings do I have going on with my settings down here on the bottom with these icons as well? Okay, so that's what that profile means. Nothing to really worry about. So settings, CARLSON configure, that was my startup settings. So where things start or what happens when it starts. To the left of that are my project and data folders. So if I click that, and here's where you saw that in the right here, this business where we talked about earlier before, the project folder, drawing folder, and fixed folder. And again, by default, drawing folder is where it's going to follow the drawing, and my startup project data folder is, when I first start, it's going to start looking here. That's my default. I could point that to a network drive, whatever makes sense. I now have the current project folder because I've saved this drawing is in this 2021-07-28 civil class, then data sets, and it goes on out to the end of it. That's where that folder is, and the current data folder, current project folder. Those are all set based on me using this model. A couple of other things, I can use the data folder to store settings, but I don't want to. I'm going to store my settings, and that's why you saw earlier when I went to save settings, it wanted to go to CARLSON Project Settings 2021. If I said use the data folder, then every time I save settings, it's going to go wherever that drawing is, and I'm not going to be able to load. Well, I'll be able to, but I have to remember where I put them. But if I make these a global location, then anytime I want to load those settings up, I can get them from a single location. So that's a way to share those among other users in your organization as well. And so this is my startup settings. This is my current settings. Most of the time they're the same. As you can tell, they might be different. You could have a server that held the settings, etc., and do all kinds of configurations for that. A current project file. I'm not using the project model, so that would be something I could use. Again, I could use project-wise. If anybody's familiar with Bentley software, that is a model that I can use to store my data. So that's available. Now, I told you earlier that I was going to show you a little trick that you could use if you ever needed to figure something out. So if you go into this choice, the project data folders, just like to here, switch it temporarily, but we won't save it. We're going to switch it to the project folder model. Okay. And when we do that, notice these two buttons underneath here will now become active. So I can then set up my subfolders. That's the first button. So if I look at my subfolders, this would be, now yours may be empty, but this is something that I had set up. So I've got like photos, plots, surveys, outgoing emails, administration, drawings, whatever that happens to be. Is if you were using that model. That may be empty for you. But look at this button over here where is the data type subfolders. And what that allows me to do is to take any of these CARLSON type of files and assign them a location to go to by default. And I can look at them by category. I've got civil, curb transition tables, cut and fill labels. I've got civil and survey, things like line and curve annotations, center line files, template curve coordinate files. I've got general, so I can look at these separately, although I don't understand why civil only has 2, but that's okay. Survey's only got the 4. I guess most of those are in the combination. Or just go up here for all. But here's the interesting thing that I wanted to show you. Let's say you've got some files that you see and you don't know what the file happens to be. You got a file that might have I don't know, pick an extension. So if you don't recognize the file, if you go into this command Just go to the CARLSON configure, go to the project and data folders, switch it to project folder, hit that button there. Now you've got a list of however many files there are in this particular build version. There's 247 different file types. And there is a file called .zon that is an earthwork zone definitions file. Or I've got a tab file. That's a hydrology peak flow file. Or TIN, there's my triangulation surface file. So every one of those predefined files is described, and the extensions are in order. And of course, you can sort them by simply clicking the heading of the column. And of course, if you're using that storage model, you can assign the folders that those data files go in by default. Right now, they're all set to just go to the project level. But if I said culvert settings, and I might have one of my folders here called, well, I don't have any hydro type folders. So, you can, here's my coordinate file, for instance. I'm saying, look under project survey and points and a folder called points. Okay. Remember that was, in this case, project survey. That's interesting. This is not supposed to stick. This should only, that's interesting. This saved from a previous version when I had those folders. It normally wouldn't show that. This particular folder, survey and points, those folders don't exist in my subset. So they're sort of out of sync. What that means, though, is that if I were to use that model and go to save this file, it would actually create those folders for me the first time I needed it and look for the coordinate file in that location. All right. So anyway, but that's the little trick. If you're not using that, to switch to it temporarily, hit your data type, find out what the file is if you need to find out one of those nearly 300 file types. Okay. And then I'm going to switch it back to my drawing folder or just hit cancel so that I'm back out to this. Now I've got two more settings to talk about here. First one is my drawing setup. That's the one over on the right. And this was what happened, but a little bit further defined. But this was what that drawing wizard, when I did the startup, that startup wizard did. I wanted it to be by default looking at English, 1 inch equals so many feet. And right now, because I set that to 30, it's assuming that I want that to be my starting point. So I would leave that at 30. And now my vertical scale.
Hey, Ken.
Yes.
I don't know why, but I can only see half of that settings menu. There we go.
Oh.
Thank you.
Wait a minute. What? So you could only see half.
Now I can see all of it, but then now you're covering and now it's gone.
Really? Do you see this column called properties? Do you see this?
Nope.
Do you see over here where it says
Nope.
properties?
I'm seeing all of it for what it's worth. It's still showing up on my end.
Yeah.
Let me change my view, maybe.
It looks to me like you're zoomed in a little bit.
Okay. It says zoom ratio 100%, original size.
Try fit screen if there's an option for that.
Now I can see all of it. Sorry for the
Okay, good. I'm glad you told me that. I didn't realize you could clip that like that, and I didn't realize it would show up, because that would be unfortunate. If if you couldn't see the whole screen. So, all right, so now when I go back to this drawing setup, now if I have it over here, you can still see it all, right?
Yes, thank you.
Okay, good. All right. So there's my, I set it for English, my horizontal scale is set to whatever scale I might typically use the most. My vertical scale, now this is a thing that is used for when I plot profiles or cross sections. So if I'm in like a lot of places will have like this will be a 50, but vertical scale would be 5. So 1 inch equals 5 feet vertically, but 1 inch equals 50 feet horizontally. So that's a 10-time exaggeration vertically. You would see that more often out in your part of the world, Kaylee, than we do here in Western Pennsylvania. We've got some mountains, not huge mountains, but they're still there. So we would typically only have a 5 or sometimes even only a 2-time vertical exaggeration. So anyway, these are just some defaults, and they're changeable anytime, anywhere along the way. You could, let's see, I'm going to make that like a 5 times. So I'm going to make a 10 vertical and a 50 horizontal. Now, here is that. Remember I told you about that symbol size to be a 10th, my text size to be 800ths. And this line type scalar, there's that word scalar, again, plotted inches. I'm going to set that right now to 1.25, but I'm going to show you something a little bit about that here in a minute. That it doesn't really matter what this happens to be. Now, the symbol name by default is going to be my default symbol. If I hit select symbol, and I've got a bunch of categories here. I've got some custom points. You go back up a level. 3D LS, back up a level. Some wipeouts, and these are points that, and I don't have any in there, but they're points that have white backgrounds instead of open backgrounds. And up here at the top, I've got a pull down list of different categories. Points is what normally is there, but I could go to trees, and I've got a whole bunch of different tree symbols. You get the idea. Inlets and manholes. Okay, and you can have these, and these are all set up with your library maintenance that you can use. C&G, that's that survey system I was telling you about earlier. And it, there's some you might find it some use. So if it ever gets to, like, there's a plug valve. There's not a lot of people. Here's a what does it say? Professional land surveyor. Some of them that are just not really necessarily of any use, but some might be something. And then there's some 3D buildings. I don't have any in here now. 3D people. Again, most of my stuff is missing. Apparently, there's some signs. 3D trees. You get the idea. Vehicles. And then this NCS. These are the National CAD standards. The typical things that started at least to be defined as a nationwide. Here's some from Massachusetts DOT. I don't think there's anything in there. They're all missing, but they're there. At some point they were. Why they are no longer here, I'm not sure, probably because of the hundreds of times I've installed and reinstalled. But anyway, that's where that happens. The key thing to remember from this is to Know up here at the top that you can pull down this list of categories and set things. That part's easy to forget. Now I'm going to set my default symbol. I'm just going to choose this SPT10. Here's one other thing to look at. I'll show you is down here is this. You can search for a particular one. Let's say if I knew I had a symbol called FH for fire hydrant. Get that so you can see the letter. There it goes. And if I search, I didn't find FH. So I'm going to go back to points. Maybe it was, instead of FH, maybe it was HYD. So there's some, oops. HYD. If I search for that, though, it found fire hydrant 3D1, 3D2, or hydrant and hydrant. They're in these different locations, but they're not loaded. But if you had one, you could use it. Let's see if I've got SCWER. Let's try. Wow, this is there we go. I'll look for control points. So I just wanted to show you that they're here by the ones that are loaded. So if you've done your symbol library maintenance fairly conscientiously and given things names like that, you can search for them here. And there's also this thing called CARLSON Community, in which case this is going to go out and find things out in this group of online users where I've got some categories. There's like CSI, which is, crime scene investigation. Bikini bottom, top, blouse. I don't know what those are necessarily used for. Probably just sketches in case there was a crime committed at the beach, I guess. Boots, army boots, cowboy boots. So there's all kinds of, there's rifles, legs. Wow, there's all kinds of stuff out there. So these are all, from certain people at different times. Get this. Oops. Different categories here that you can sort by. You can there's names by et cetera, et cetera. Here's, for instance, mining, surface mining. I've got a 3D haul truck, two of them actually. And Dave C, that's Dave Carlson, he's the chief programmer. So you can see that these are, here's the manual of uniform traffic control devices. There's something for you that Matt, you may be more familiar with. So these are the actual MUTC symbols. So you can download any and all of those or simply view them. There's the interstate one, et cetera, et cetera. So, there is a wealth of information out there. There's Russian and CIS. You can even, create your own and load them up, create a category if you belong to that CARLSON community. So, don't lose sight of the fact that those things are there and available to you. All right. Now I've got to go back and find this symbol correctly. It's reset it. I'm just going to set this to SPT10. There we go. Now, the rest of the vertical angle mode, I'm set to none. This has to do with if I'm creating uh, coordinate geometry commands. If I'm computing a point location, do I want to include vertical angles? Well, unless I'm entering surveyed observations, I don't need to do any kind of a vertical angle. But if what I'm doing depends on a difference in elevation, then I can set that to whatever I need to be. And here again, my coordinate system, either a local system or a grid system. And if I set it to grid, then I would set whatever uh, grid that I wanted to come up by default. Now, my English units, US feet versus international feet. I want to use US feet at least for the next year or two until they switch that. And that has to do with the fact of the way our survey instruments and our survey legacy data was defined. And it was on the old definition of a foot, or of a meter rather, meaning that there were exactly 39.37 inches in a meter. All right, so that gave a particular conversion factor, 0.3048, blah, blah, blah. Now, the international definition of a foot is defined based on there being exactly 2.54 centimeters per inch. So multiply that by 12 and you get, a different conversion factor for the meter. It's like 3.2808 or inversely 0.3048, whatever those numbers are. But they differ out in about the seventh or eighth decimal place, which doesn't really matter on something small and localized. But when we're talking about working in state plane coordinates where the numbers, the northern and easting coordinate values are in the millions, or if we're doing long projects like pipelines that go across country, maybe cut through 3, 4, 5, 6 different counties, then or roadways, for multiple mile plus long roadways. If you don't have those matched to the proper use of where your survey data is coming in from, if one of you is using US survey feet and the other one is using international feet, you're going to start to see some difference. It's going to show up. So anyway, it's a hotly, I wouldn't say debated, but hotly discussed topic. So this is basically setting up our defaults as we want to do things for a new drawing setup. Now, to finish this out, I'm going to choose this attribute layout ID. By default, it's 0. You can see as I change these different IDs, these are the attributes of a point. The point number, the elevation, and the description, and that's a little preview of what those look like. In which case, this would be, the point would be in the middle, the point number would be above it, the description below it, and the elevation off to the left. The default one is opposite that, the point's above, the description's below, and the elevation's off to the right. My preferred is this one where they're all lined up left justified, and the point itself is just right there in the middle off to the left. That's my preference. And again, whether I'm going to use descriptions, whether I'm going to use elevations, whether I'm going to locate these points in, on the real Z axis instead of keeping them down at 0, which you could do, but the elevation value is stored. But I'm going to go ahead and position them here. I'm going to turn off my instrument rod height and my prompt for symbol names. I will label zeros. I will set bearings. I'm going to set my point numbers that I want to use. I'm going to have it automatically use point numbering. And I'll go ahead and use the drawing template. We talked about these down here below. That's all good for a starting place. I'll say okay. And now that's stored. Now, I'm going to go back here to saving this settings. I hit the Save As button, and now I notice it points me to that settings 2021. And now here's where I like this Carlson dialog because it gives me that recent file. So I just simply select that file there and choose save. Yes, I'll replace it. So now it's updated those if I ever needed to do those. And we're going to come back. We'll go ahead and take our lunch, but we'll come back here after lunch and we're going to talk about these general settings because this really, and this section right here in this middle part is going to have a great influence on how the software works. So I want you to understand those and we'll get a chance to play with some actual drawn elements and see how those work. We'll come back, okay? So we'll pick that up. Now, if I say okay and exit myself out of this, here's one thing that it will do. Because I'm in a drawing, remember I set mine up to be 30 scale when we first started. Well, I set my startup options just now to be 50 scale. So it says, hey, your drawing setup changed. Do you want to apply that to the current drawing and to future drawings or only to future drawings? So I'm going to say future only at this point. So I'm saying I'm still going to stay with what I have set up and I'll just leave those set like that. And if you've got anything that you want to save, hit your save icon or pull down file, choose save. And we will come back after lunch. It's just 3 minutes after, so I'll tell you what, I'll give you an extra 2 minutes. We will restart after lunch at 1:05. And with that, anybody have any questions so far? All good?
All good.
Oh, I will stop our share. I will pause our recording. And screen share. Okay, everybody can see okay?
Yes.
Okay. Now, we're going to talk about a couple of settings that are sort of important to your work because they affect the way things are generated and the way they respond to certain things. So if we go to our settings menu, CARLSON configure, and let's look at the general settings. And this is where we have the bulk of the way things react when they are being used or queried or created. And some of the things over on the left are just some general options. And you see this upper checkbox, this Use Startup Wizard. That was that checkbox I showed you when we came into the drawing in the Startup Wizard. Down in the lower left, it said skip Startup Wizard next time. And if you turn that off, this is the only place that I'm aware of that you can turn it back on. So that is, if you ever need to do that, that's where you turn it back on. Now, this generate report log, and what that does is it logs all of the reports that you may run into a separate file. So it's sort of like an audit trail for that. It's not necessarily anything that I found to be of much use, other than it does start to eat up some disk space for you. So if you need to get rid of some disk space, that would be a good use for that. The reason I say it's not terribly useful is that all of these reports can be run at any particular time. And there's even a command on the inquiry menu that says display last report run. So even if you've just run a report and dismissed it, you can get back the last one that you've done without having to set anything else back up. Same thing with the drawing save log that just keeps track of who saved the drawing, when, which user ID was logged in. And so it could be of some use if you're working in a larger organization and you need to keep track of that. The drawing INI files, you do want to save. That's a text file that keeps track of data files that are associated with your drawing. So if you've opened up a series of different coordinate files, or you've created multiple surface files, all of those things are listed in there and where they happen to be on the system. So that's useful in case you share this information out with somebody else and they need some of those support files that you may or may not have included in your transmittals. They can help you recover that. Save settings to the drawing dictionary. I'm not sure exactly. Pop into this configure, see if it's documented. It might not be documented. We'll see. Yeah, save. Here it is. So this option saves settings for commands within the drawing. So if you run a command like to station a center line, for instance, it will save those settings within the DWG itself. So they're always saved at the program level. So the next time you run the command, the settings that you used the last time you ran it, regardless of which drawing you're in, they're available for you there. But if you store these within the drawing, then each separate drawing will keep the command settings used in that drawing the last time. Okay, so again, if you set your contour interval to 5 and you're in this particular drawing A, and if you set your contour interval to 1 in drawing B, then the next time you open up drawing A and run the triangulate contour command, it recalls the number 5 that you used the last time in that drawing instead of the last time you used it, which might have been this drawing B. So that could be a useful thing. That's actually a new setting. I'm not sure, Kaylee, if yours has it or not, if it has that setting or not, but that's actually something that might be of some use to save those settings to your drawing dictionary. Ignoring zero elevations is a handy switch to allow you, when you do generate these surfaces, what that says is that even if you select elements in the drawing to define the surface and they happen to be at zero elevation, they will be ignored. So that's useful if you are in a part of the country that has some elevation above zero. Like if you're not down around sea level, down on the coast, that's a really handy switch. If you are, say, down in Savannah, Georgia, and you have some possibility that you have things that are actually at zero elevation, but they should be used to define your surface, then you would want to uncheck that. And all that means is that you have to just be a little more careful when you select the objects you want to use to create elevation items like surface models. Using south azimuth, meaning you would set the 0 to the south direction instead of north like we use in North America. They do use south azimuth in other parts of the world. And this D view twist angle, that is your dynamic view set to a twist angle, which is a rotation of the screen without actually rotating the drawn geometry. So you might set it up so that north is actually pointed off to the upper right instead of straight up the page. Just a nice way to keep those in sync. These next 5 or so, 1, 2, 3, 4, 5, 6, these set up some of the CAD system, what are called sysvars or system variables, like dimension scale to the drawing scale, the angular units set to the drawing angle mode, whether you're using like bearings, survey type angles, or if you're using decimal degrees or degrees, minutes, seconds, it just matches those up. Now the PD size set to the symbol size. The PD size is a point display size, and it doesn't have a lot of effect for us unless you are using another variable called PD mode, which is your point display mode, to represent CAD points. Now, not Carlson points, but CAD points, the actual point entity, to display other than say just blank or as a dot, which is the default as a dot. We'll take a look at those in a little bit. So that just synchronizes that to the symbol size that you are using. It could be helpful. It's not, I don't ever use the point display mode myself as anything separate. Then set your insertion units to unitless, and that's helpful for when, like if you're using, if you get a lot of architect's plans that might be done in architectural units, and they typically come in with their insertion units set to inches, or if you set them to unitless, then it ignores that setting and you'd have to put it in as a scale factor of 12 because architectural units are based on inches and not on feet, although in our world, we don't actually define a unit of a foot. We just use the unit of whatever it happens to be, whether it's parsecs, microns, meters, feet, miles, furlongs, what have you. So not terribly important, but if you share your work with other people, this will keep that set to unitless, even when it might be defined through the units command to be something different. Set the user coordinate system to world on startup. So again, it's something that I'll show you really a means of visually recognizing those user coordinate systems, making sure you're in the world system. Set the LT scale to the drawing setup LT scale, and that's the line type scale. We'll talk about that a little bit later as well. Now this next switch, you may see use software rendering. Yours is probably off, in which case leave it off. Mine is on because I'm running under Windows in an emulated environment, which means this emulation intercepts calls to the graphic processor and has to intercept those and feed them as software because it doesn't have support at the hardware level for the graphics adapters. But this will speed up your visualization of things if you keep that unchecked. If you should ever have issues with your graphics adapter where you get some weird kind of graphic behavior, you might need to set that to software rendering. But generally, if your system can run a CAD system successfully with the graphics adapter you have, then leave that unchecked. Okay. Enable the file selection graphic preview. That is when it asks you to pick a file in your file dialog boxes. Certain files have a little graphic preview that's helpful. Use a dialog for a selection set filter. And that's when you're selecting objects and you're going to filter them by certain things like only those things that are on certain layers or with certain colors or certain line types. And that just brings up a dialog box that lets you check those on and off. So that's helpful as well. Manage your workspaces automatically. Your workspaces happen to be a setting down here that you see this little gear. It's also, I think I may have it up here in the top somewhere in one of these toolbars. I don't actually see it up there anywhere, so it may not be out in the quick access tools. I don't have those showing. But again, that's just to allow the CAD system to track that. You generally don't switch those around if you're working in a CARLSON environment. That's just a CAD thing. Like if you're going to switch over and do 3D solid modeling to design and build toasters, for instance, you might want to switch workspaces, but generally you wouldn't. Now the coordinate order, typically with surveying and even engineering type things, when we generate a list of coordinates, we like to see the north value first and then the east value second. Well, if you look at the way things are set up in the CAD system, north is typically straight up the page. Well, that's the Y axis, and east is the X axis. So the default coordinate display that you see, say down here on the bottom of your screen, if they are showing, is always X, comma, Y, comma, Z, if you have something with three-dimensional coordinates on it. So the CAD system is always wanting to do X first, which is east, and then Y, which is north. So that would be your east and north. But when you're talking about coordinates in the drawing, from an engineering or surveying perspective, we typically use those as north and east. Now, using annotated scale, I'm going to leave this off for the duration of the class just because it can sort of be a little bit confusing. What that means is if I say use annotative scaling, then when I generate text, like in a coordinate, if I put a coordinate in the drawing, a Carlson point, and it puts the point number, the elevation, the description in at that size that I told it, at like 0.08 inches, and it does the calculation, say at 30 scale, then that would be 2.4 feet on the ground. That's how tall it would be. So that would be 0.08 inches at 30 scale. Now, if I'm using annotated scaling, when I do that, let's see, second. Sorry about that. That was Mike actually calling in. So if I do, if I use annotated scaling for that text, so it's 0.08 inches at 30 scale, and then if I were to go up and maybe over in one of my paper space layouts, and I change the scale of that viewport, it's going to resize that text automatically to keep it at 0.08 feet at whatever scale that or I'm sorry, 0.08 inches on the paper at whatever scale I set that viewport to be. Okay, so that's a CAD thing. It has nothing to do with Carlson, other than Carlson will use it if you have this checkbox on. Normally, when I'm working on client projects, I do use those things, but I don't want to get into a lot of confusion right now, so I'm going to leave it off and suggest you do as well. If you're comfortable with it, go ahead and leave it on. I did note that in previous versions prior to 21, and it might be yours, in your case, Kaylee, on 2020, anytime you go to draw locate points, when you draw a bunch of points, the first point doesn't react to that correctly. All the others do. The first ones, you would see the labels would be real super tiny. You'd have to redraw that point. You'd have to be aware of that. But in any case, it's there. So if you do turn it on, then you can set these other switches as well. Then finally, the date format, dates reported, the document format. Anytime you generate a drawing, or I'm sorry, not a drawing, although it would apply to drawings as well, but even a printed report and stuff, when you save those off, it will by default go to these two options. The DWF is a drawing format or an AutoCAD based file. It's not a DWG file, but it's sort of like AutoCAD's response to PDF. It was a DWF. It's not very popular, but it's there if you want it. And then finally, the report viewer, you can switch it to between the Carlson viewer, the internal viewer, the Windows Notepad, or Microsoft Word, whatever your preference is. I like the report viewer, and you'll see why when we run a couple of reports. There's some tools in there that allow you to append an existing file if you want, or you can also dump the report text into the drawing as if you had run the multi-line text command and typed in a bunch of text. So it's a nice little handy thing. Now, switching to the right-hand half, the coordinate file format by default uses CARLSON alphanumeric. And what that means, as opposed to CARLSON numeric only, which used to be the only version you had, is that that allows point numbers, if you will, to have alpha characters in the number. So you could have point number, 1, 2, 3, 4, 5, 6, 7. But if you wanted to make a point 5A and 5B, so if you have 1, 2, 3, 4, 5, 5A, 5B, 6, 7, 8, 9, then that allows that functionality. Now, that only really affects us in the fact that we can certainly give that point what they call a point number. It's really a point name. So we can give it numbers as well as alpha characters, and they go, they go into sort order. So this comes into play, for instance, if you are working with points, CARLSON points, and you want to draw lines. Say you have 10 points and you want to draw from 1 to 2 to 3, etc., all the way up, and you go from 5 to 6 to 7. So you would put in the line command. You want to draw from point number 1 to point number 10. You would say 1-10. Okay. So then let's say later coming on, and that applies to things like the field to finish system, which will read those points and draw lines sequentially between those point numbers. So let's suppose then you needed to insert a couple of points you forgot. Let's say between 5 and 6, you had 2 other points that you missed the first time, and you wanted to go from 5 to the first point you missed, and then the second point you missed, and then pick back up with 6. Well, instead of having to renumber point number 6, 7, 8, 9, 10 to be point number 8, 9, 10, 11, 12, and then change those 2 new points as 6 and 7, you could just put 5A, 5B, and then it would draw from 1, 2, 3, 4, 5 to 5A to 5B, and then to 5 to point number 6 and 7, 8, 9, 10. So the same command would still accommodate the insertion of those points with given alpha characters. But in any case, that's our default. The other choices, this CARLSON SQLite, SQL Lite, it's called CRDB. This other one, these other two up here are both CRD files, but a CRDB file, that is a database or a database based coordinate file. So it actually goes into a database file as opposed to just a file holding points. And this allows you to link GIS information to those points directly in that database. It holds GIS data, it holds point comments, it holds other things that relate to the points. If you're not using that, it still does the same thing, but it has those as separate files. So it has a CRD file, but there's also a GIS file. There is a I think it's a DES file, the point description file, and they link together. They correlate, one record matches a record in these other files. So not really much difference in functionality, but if you do use it, and if you're tracking GIS data with your points, you can go into the point editor and actually edit the GIS attributes of those points. So it might be something to keep in mind if you might want to start using GIS data along with your points as well. These other three have to do with, there's that C&G survey system I was telling you about earlier, same thing, numeric and alphanumeric, and the simplicity systems ZAK format. So those are just some options you can use as your coordinate file format directly. The CARLSON alphanumeric is probably fine. Now we're going to skip over this object linking here for just a second and just finish out these two things here as well. The remove arcs section, and you see that little outline around that box. So that contains this choice here and then these values here. And it's either going to be by a maximum offset or a chord length. We'll talk about that, what those mean. And then you tell it what the maximum offset is and what the chord length is. Now, how those apply, and well, actually, before I talk about that, let's just jump down here to this digitizer settings. I'm going to say use mouse. If you are particularly a contractor, some of them still use digitizers and to trace drawings that they may get in from an engineer to generate graphics. But we're just going to use the mouse for now. We're not going to worry about that. So um, you can leave yours here sitting on this page. I want to show you what this maximum offset and chord length actually is involved, or how it is used. So if I have a drawn line, let's see, I'll keep it as yellow here, and if I go from, say, so my mouse comes back from here to here, and then I set an arc, and I went, let's do it this way, and then I'm going to go back to line, and say, go over here. Now, so this is a polyline that was drawn, and it has an arc as part of that polyline. Polyline simply means multiple lines. So I've got a line, an arc, and a line all put together as a polyline. By the way, Carlson loves polylines. I'm getting the habit of using polylines instead of lines, but you can still use lines. It's no big deal. But it keeps them all together separately. Now, what this does, if I select this line, this polyline, and I look over, I have my properties palette open on the left. If you don't, you can right click the mouse in the blank space, come down below and choose properties, and it will pop that box up that you can then dock on the left hand side, or you can just pop it up when you need it. And if I look at this, I have an elevation of 0. Okay, and I see up here that it is a polyline. It's two-dimensional. Okay, and that elevation doesn't have to be 0. It could be, let's say, it's a contour line at 100-foot elevation. So I could make it, I can set it to be 100 feet. And if I look at that, notice when I get the mouse near those dots, it's going to jump into that dot, into the vertex. And I'm going to look down here on the bottom of my screen. These are my coordinates that are being tracked. And if you don't see those down here, go over to the right hand side. I think is where I'm going to set those up. That's my status. I don't see the setting there, but if I write, yeah, okay, just down on the status bar, if you don't see those coordinates out there, just over on the blank spot, if you right click it, you'll get this menu to come up. You may have on the AutoCAD version, Matt, you may see a button over there that looks like a gear or something like that that sets it up. And this, you turn on and off the different things that you want to show up down here on the status bar. And the one that we're talking about are these cursor coordinate values. That's the first one up here in my list. Okay. So that displays the coordinates in a continuously changing set of numbers as the cursor moves. But if you let it sort of snap into those vertices, you can read down there what those coordinate values are. And that means it is a value of 7.3915 x, comma, then 6.1446 y, comma, and then 100.0000. That's the z value of that coordinate. That's its elevation. Now that's two-dimensional. It's all flat. Okay, but it is at an elevation of 100. So the reason we have in your settings where it said arc conversion by maximum offset or by length is for this reason. I'm going to draw another line. I'll make it red. And I'm going to snap to that endpoint. I'm going to snap to that endpoint. And I'm going to snap to, say, the midpoint of this, and then snap to that endpoint and snap to that endpoint. Okay, now what I've done is created another approximation of this yellow line. Now I don't need to do this if it is a constant elevation, it's two-dimensional. But if I want that yellow line, if I want to turn that into something that has changing elevations from, say, this point to this point to this point to this point, for instance, if that's the edge of my curb in a parking lot, all right, you can imagine that that's going to have differing elevations along it, unless we just lucked out and it all got built completely level. So to be able to use that then as a three-dimensional piece of information, I have to convert that drawn 2D polyline into a 3D polyline. Well, a 3D polyline then is composed of things with differing elevations at their endpoints. And here's where the rub comes in. This middle part is an arc, part of a circle. Now, I cannot represent that part of a circle with differing elevation from where it starts to where it ends, because if I were to do that, for instance, this, I'm looking straight down on it, but imagine if this is an elevation of 100 and it goes all the way around here and it climbs up, as I'm walking around, it climbs up to this end, it goes to 105. That means that point is 5 feet in the air above this one. I'm looking straight down on it. It still looks like an arc. But if you stretch this point up 5 feet in the air and then turn your head, reposition your head so you're looking straight down perpendicularly to the shape of that when it goes from 100 to 105, so you're no longer looking at it vertically, then that would no longer be in the shape of an arc. It would be stretched out. Okay, I'm not sure if you can follow what that means. But if I pull this up in the air and then look at it perpendicular to its new shape, it would be elongated instead of being an arc. It would be, stretched out in this direction between the two endpoints. Okay. So the way this gets around this limitation, and this is true no matter the CAD system. There's no CAD system in the world that can make a three-dimensional arc. There's no such thing as a three-dimensional arc. There are helices or helix geometry that can do it. But the way it has to get around it is that it approximates this curve by providing a series of little line segments in between it, all the way along that distance. And so here then is, I'm going to change this to a different color now. Here's how this applies. If I go from, I'm going to go perpendicularly to, my mouse is lagging, I apologize. If I'm going to go there and then do the same thing from to perpendicular to this. And then I'm going to move this from here to the midpoint up here. And I'll move this one from there, and I'm going go from there up to this intersection point. All right, so sorry, my mouse is having issues here. Let's go to, oh, sorry, it is an apparent intersection. There we go. All right, so we have this distance, and we also have this distance. So here are those two settings. This distance from here to here is a maximum offset, and this distance from here to here is that, I'll go back to my CARLSON configure, the cord length. Okay, so it's whatever these numbers are, I'm going to say I want to use the maximum offset method, and I want that maximum offset to be no larger than 0.02. So when I approximate that yellow arc with my three-dimensional geometry, and I zoom in and look at it, I'm going to see these little bitty line segments all along there, such that the maximum distance is no greater than this amount. Or if I chose the chord length method, it would be whatever this number is. So quarter or 0.25 feet, I would say, all right, go along this, and every 0.25 feet along there is where you would start to draw those chords. And it does it all the way along the circular feature. All right, so that's the remove arcs function. Okay. And also, again, you can just keep, you can keep your stuff showing up there, and I'm going to show you what this happens to be. So if I want to turn this into a three-dimensional arc, and I do that with my 3D data, 2D to 3D, I'm going to say by start and end elevation, I'll just choose this. And I'm going to go from 100 like it is, and I'm going to say go to 105 up to this end. And I'm going to choose that. Whoops. All right, it did not, it didn't keep the original arc. Let me draw it back. And I'll make the original red. Right, and from here to here, and from arc to here. All right, so now when you see that approximation was done with these line segments. So that distance there is going to be less than that 0.02 that I put into my settings. Okay, sometimes it's smaller than, but that's the way it worked out. Again, you can see the chord distance would be limited to that as well. Now, why those numbers are important? When you build terrain models, every vertex that it encounters as it creates those features, when you create this triangulated irregular network, this 10, it's going to put a corner of a triangle at every vertex that it sees, that it considers. Okay, so if I have that number set super tiny, I use 0.02. If I had it set to something like 0.00001, then I'm going to get a whole lot more vertices in here. And that may be okay, but the more that you do, the more triangles you're going to have in that resulting surface, and they may not really improve the modeling any. It may just be a whole lot more triangles, and it has to read those triangles when it goes to do some processing, volume analysis, or cutting profiles and things like that. It has to read each one of those. So the more that you have, the slower it's going to operate, although it's not terribly much of a problem with, considering today's computers. Where it does get to be problematic if you have too many of them is when you're using machine control and you're going out there trying to build this stuff with a bulldozer, and it has to also read each and every one of those triangles as it goes along, and you could get more data than will fit on those controllers. So you sort of have to get a something that is close enough that approximates it. So to me, 2/100ths of a foot, which is pretty tiny, just a millimeter or so or two. Uh, that to me is close enough, particularly when I'm building things. So that's what that setting does. Okay. Now, back to the ones that we're going to play with here. CARLSON configure general settings. This business here in the middle, object linking. Linking points with coordinate file means when you're using CARLSON points and you have a coordinate file, your coordinate file can have any number of points in it, and your drawing file can either have all of those points also in your drawing, or they can have no points in your drawing, but your coordinate file has points, or maybe you've only got a subset in your drawing. And sometimes if you move the drawn points in your drawing to a new location, if these are linked, it's going to automatically update the CRD file data to match where you've moved it in the drawing, even if you just moved it with a CAD command. This has, in recent versions, they've really put some safeguards on here where it always, regardless of this setting, they're always going to tell you that you are now different from the CRD file. Do you want to update that location? So that's a means of sort of keeping that in place. In older versions, it didn't even warn you. You just had to know what this was set to and make sure that you understood that if it's not linked, you can move things in the drawing freely and it doesn't change the CRD file until you purposefully run the command to bring those back into sync. And this happens like surveyors would get a whole bunch of points around an area, and then they would zoom in there and they would just willy-nilly move the points out of the way so they could see what they're working on, because they knew they could go back to the CRD file and redraw the points, and it would put them back in their original locations. Well, that works okay if everybody's using that. The problem is, in some companies, some people would have it on, some people would have it off. And if multiple people are working on that drawing file, then whatever was in play when those points were brought into this drawing, that's the way those points reacted. So some did link, some did not. If somebody else had this unchecked, then they could be freely moved and would not update that. So that's something that I would recommend that you have on, and that everybody who works on these has those the same. The next, linking line work with points, means when you draw lines using CARLSON points, where you've told it, use this point number, then if you move the point, the line will redraw itself to follow that point. That's a one-way link. If you simply grab the line and stretch it out to a new position, it won't move the point. And then also, if this is on and you do that, and you move that line out to another spot, it doesn't move the point, and it stays out there until you regenerate the drawing and it rereads all that and recreates the line. So having moved it, it now goes back to where it was. So this is something that you need to look at to see if it works the way you want it to, on or off. It's not a one is better than the other type of situation. Same thing with labels and line works. If you have this on, you'll see the labels update. Linking line work with center lines. Again, if you create a center line and you draw it, and then if you just graphically change the drawing line work, it will update the center line file definition, and vice versa. If you update the definition and save the file, it will redraw the line. Grouping the point entities means to group the point, the CAD point, and the symbol, and the block that holds the attributes, or the point number, elevation, and description, all into a single group entity. So if you select any one of those, you're selecting the whole thing. So that's generally what you want to have happen. And then finally, maintaining the coordinate history file. This lets you roll back changes to a CRD file, any points that you've made, if you have that turned on. So it does keep a separate file, and it lets you step through those changes and undo back through a certain point. Now, you can't skip down and undo a particular one. It undoes all the way down through that particular change. So, but sometimes it will help you recover if somebody's made some changes that shouldn't have been made. All right. So what I want you to do right now is go ahead and turn all of these on and make sure they're all checked so that you can see how this stuff works. And we're going to try our hand at a couple of things. And we're going to say, okay. And then we'll say exit. So we've cleared the decks. And I'm going to erase everything. So I will choose my erase command. It asks me down on the command line to select my entities. I'm going to say all. And now they're gone. I've got a completely empty file. And I also look on my points menu at my list points command, and it should be completely empty. I'll say all, say okay, and I see I have 0 points. So I can create some points by going to the points menu and draw locate points, or as an alternate, let's set a coordinate file to a file that has some points in it. So when I do that, I've got 2 tabs here at the top, new or existing. I'm going to choose existing, and I'm going to choose exercise 1 coordinates.crd and open that file. Now notice up at the top stripe, I've got a coordinate file showing me its exercise 1 coordinates, and I've got a drawing file that says I'm at class example 1.dwg. Now you see the little asterisk by the DWG. You see it also here on the tab. That simply means that it is now in an unsaved state. If I were to save my drawing with my save icon, the asterisk goes away. All right, that's just a little visual reminder. So what we've learned here is that we've set a coordinate file. It's a different name from the drawing file, so those don't have to match. And I can switch in and out of various files anytime I need to. So I'll go back to my points menu, and I'm going to list my points. And I'm going to choose all points, and I'm going to say okay, and I see, well, sure enough, I've got 22 different points, and there are the point numbers, the northing, the easting, and the elevation, and the descriptions. Now there are no descriptions on these points, they're just blank. And I'm going to choose this exit button, and now I have those points, but they're not in my drawing yet. Okay. I have to create them into the drawing, and I do that on my points menu. And I say draw locate points, and I can change to a different symbol. I can put them on particular layers, different layers, set their sizes. There's my symbol size, there's my text size. You may recognize those from the defaults. And I'm going to now choose the button down here to draw all. Notice you can screen pick, so you can just pick places on the screen and it creates them as you go. You can enter in a sign where you would type in the coordinate values if you knew them. But if I just choose draw all, it's going to draw them into my drawing. And yours will probably respond much faster. There's something about doing this across Zoom that sort of lags this stuff up, and you'll see this progress bar down here on the bottom. It's not a very large command. All right, so there they are. There's all my 22 points. And and if you didn't see them show up, just type Zoom or Z and hit E for extents, and then that puts them there in our list. And you can see as we zoom in, I've got points, and there's 9, 10, there's 6, 7, 8, 1, 2, 3, 4, 5, 6, 7, 8, all the way around to the end of everything. Okay. Now there's a shortcut for zoom extents. If you double click the wheel on your mouse, that's the same thing as doing the zoom extents. All right, so what happens is with this linking. So I'm going to go over here to my toolbar, my draw toolbars, my 2D polyline, or I'm going to go to the draw command or the draw menu and choose 2D polyline. And if I give that a starting elevation, it will hold that elevation all across the entire length of that polyline, or if I just leave it at 0. And I'm going to make sure that this autocorrect for 90-degree corners is not checked on, but that's a way that if you're drawing like a building outline, you can be sort of sloppy with it and it'll square up the corners. And I'm going to use the current drawing properties instead of creating a given name or layer name and setting it to a particular color. I'm going to use the current drawing properties, which right now are on layer 0 up here at the top. The color is set to by layer, so whatever that layer's color is set to, in this case it's white, and the line style and line size or line weight are also whatever the layer definition is. That's what we typically use, are those things called by layer. All right, so I'm going to use those current properties. I'm going to say okay, and I'm just going to start looking at my command line prompt now. It says I've got an option to continue. If I can pick up from where one left off before, I can extend a segment of a particular one that was drawn before, at the same direction. I can follow something else that was already drawn. I've got some options, and that would bring up that dialog box we just saw. And I can pick a point with the mouse, or I can type in a point number. And that right there is the difference. And that's why sometimes people like to use use CARLSON points, because it lets me use point numbers. And that's why also, if I'm drawing this polyline, notice I pulled it off the draw menu and I chose CARLSON's draw 2D polyline command and not the CAD polyline command, the P-line command. But you can do either one. Either one will be absolutely fine. It's just when you're using the CAD command, it will never let you type in a point number, and it doesn't understand point numbers. It thinks you're typing in a coordinate value. So if I just pick a point, let's say I'm going to go from here to here to here, and let's say I wanted to go, say, from 3 to 4 to 5, I could say 3-5. So go 3, 4, 5, and it did those. And then let's say I went from 6 to 10, so I would say 6 and then 10. And then let's say I wanted to go 9, 8, 7. So if I said 9-7, it will actually count down backwards. And then I could go off here and do a few more clicks on the screen and hit enter and be done. Okay. So now, what I have done, if I look at these, I see these have elevations of like 109.9, 108. So those are differing elevations, but this is a 2D polyline and it has a constant elevation of 0, which you can see that. I'm going to hold the shift key and press the wheel, and I'm going to roll it up slowly so you can see how the points are up at elevation, around in the hundreds, whereas my polyline is down at 0. Now to set that back to where it was, I'm going to type the word plan, hit enter. It asks a plan view of whichever coordinate system. I just hit enter again to take the current, which is the world coordinate system. So now I'm back on that line. If we do the same thing, draw menu, let's do a 3D polyline this time. And we'll keep those things set, except I'm going to uncheck this prompt for elevation or slope so that it reads the elevation. I'm going to say, okay, I'm going to pick a point here. So that read an elevation of 0, you see it down here in my command prompt. If I said to prompt for it, it would ask me for that elevation. So I'm going to go from 0, and I'll go down here and just keep picking these points. And now I'm going to go from, well, let's go from 17 through 20. So 17-20. And then I'll pick out here and out here. Now, the difference there, and you'll see if I zoom out and roll that up, you see how they're down at 0 until it hits those points, and now they have some elevation. All right. Now, I can set these vertices at some other elevation by any means. So I've selected this. I look at my properties, which I keep up here on the side, or you can right click, choose properties. It's my first vertex. It has an elevation of 0. Let's say if I made that 100 right here. So I type 100, hit enter, and then I step to my next one. And let's say maybe I called that one 101. And then if I go to my next one, you can see it's read the elevations of those points. You see these numbers right here are exactly what's in those point elevations. That's 160.62, and let's say we called this one 165. And let's go one more. We just drop back down to 164. Oops, sorry. 164. Okay, so now look at that in 3 dimensions. And again, I'm holding the shift key and holding down the wheel on the mouse and pushing it around. So I can see now that they're no longer down at 0, but they're still a pretty good, it goes from 100 to 101 up to 157. All right. Now, what this linking does is this. Over here on the 2D polyline, if I select this, turn the grips on, and I sit in that grip, just hover the mouse over it, and I click the left mouse button and drag it down to here. I've now changed that line. And remember, the linking said link line works with points. So I've now changed the line, but that point is supposed to be defined by point number 4, I'm sorry. But it sits out here. Now, if I regenerate that drawing, that part stays okay. But anything that triggers the coordinate file to be read, in which case if I double click this point, it points to it and it brings up this place where I can make edits to my point. I can change symbols, put some notes in, associate an image with it, do some decimal numbers, how far out do I want to go. Or maybe just set it to be a non-surface point. And if I say okay, see what it did? It pulled that back into place. So even though I changed this, if I had intended that to be down here in this area, then I need to, as long as that linking is on, I have to make sure that I move that point number 4. So I'm going to select that. I'll grab that grip. And we'll move number 4 down here and watch what happens. Do I want to update the coordinate file? Well, I'll say yes. And the line goes with it. And same thing if I edit the point, and let's just add 10 feet to the north here. I'll make that now 53 and say okay. Notice it pulled it up automatically. It didn't even tell me I was making a change because everything was linked. Okay, so that's how that linking works. And this same thing would work over here. If you change this elevation from 157. Let's make that 127. We'll drop that one down 30 feet. Notice it changed to 127. If I select that, hover the mouse, I see down at the status bar down here on the bottom of my screen that it is indeed 127. I can step through my vertices until I get to that marker. It's 127. And indeed, I could also, do that bit and see that indeed, it follows that point. Okay. Everybody see how that part works? Now, one of the other links was the line work and labels. And those are labels that are generated from these annotation commands over here. So if I go to my annotate menu and let's just choose auto annotate. And it's going to run the command. It's going to load it up and get the dialog ready. And here they are. I've got the lines, arcs, stacked arc and arc dimensions, but I'm just going to look at lines, and I want to put the angle or the bearing over the distance. So up here's where I put the angle and the distance. The first row above, the first row below. I'm just going to say okay, and I'll choose this and hit enter, and it's going to automatically label everything to be a particular bearing and distance along that feature. Now, remember when those things changed, when I move this point up here, the line's going to change. Select this. Well, that didn't work. Don't know why it lost that. Let's change that to 57. Okay, so that made it. So apparently it did not respond to a graphic change. But when I edited the point and changed its location, both linkings reacted. The line redrew itself and the labels redrew themselves as well. So that works for linear dimensions. It works for if I draw in this case, just a rectangle. And if I go to my area by close polyline, if I choose this, there's my area. I exit. I answer my lot description number 1. So there's my label for that. And if I should happen to change the size of that, it recomputes those numbers. Okay. Now it did something with this label here. I would need to then go back and set that to, instead of use original, it would be, set it up to a lot label, whatever that happened to be. The point is that those numbers reacted to the change in that drawn line work. Okay. Finally, if we draw, I'm going to draw a 2D polyline. Again, I'll go back to the draw menu, draw a 2D polyline. And I'm just going to go from here, turn that off, to here, to here, to here. Okay. I want to turn that into a center line. Now, maybe these are, this is going to represent, say, a sewer line. And I'm going to put manholes at each of those locations. So I'm going to turn that into a center line. I'm going to go to my center line menu, and I'm going to say polyline to centerline file. Now, these are up here commands that work with creating that polyline file. And I can go straight into the editor and do all that, or I can just draw it and then say, turn that polyline into a centerline file. It asks me for a name to write, or a file to write. I'm just going to call it test. It will create a file called test.cl. Select the polyline that represents the center line. I'm reading down here on the bottom, and it says, as a reminder, the polyline should have been drawn in the direction of increasing stations. If you know that and it should have started here and gone that way, then you would have to reverse that, and it'll give you a chance to do that. You can do it in a number of different ways. So if I select that, it showed those little arrows and asked me, so it gives me the option now to reverse it, or I can change it to point to the end of it, or I can, by default, with my angle brackets, it says beginning station of 0 plus 0, 0. I'll take that. I'll just hit enter. And if I look down here below, let's up this a little bit further, you can see that it creates, starting at 0 at that coordinate, and it creates a line intersection to a line intersection to a line intersection to a line intersection. If I had curves in there, you would see PC and PT. Press enter to continue, and I'll just hit enter, and it's finished. Now, that is, if I go to centerline, and I want to edit my centerline file, I'm going to go to my centerline editor. It asks me for the file, again, new and existing. Down here's my file. I see a picture of it, and I'll say open. And there now is that line, there's that line, there's that line. And I can do various things here. I can add a curve in between those. So I can add a curve. I want to keep it tangent to the previous element. I can hold the PI or the PC and go to the right, and let's make that a radius of, say, 200 feet. And I'll say okay. So it's going to put a curve in there like that. Now, as soon as I say save and exit, you see what it did? It actually changed that. Now, this linking is two-way. So if you simply go in here and change that, and even if I do what's called a fillet command, which is my in the edit menu, and this is just a fillet. I'm going to do a radius of, and I'm going to show it the distance I want to use that radius, and I'll check that and that. So that now has a curve there. And now if I double click that line, it loads up the editor, and notice that that curve and the change in that other point has now been incorporated into my editor. And I can look at the particulars, and the way I'm getting to that, by the way, is when I get up to this, you see these highlights is wherever whichever element I'm sitting on, and I double click it or choose the edit button down below. And let's make that, instead of 200 feet, let's just make that 100 feet. And so that's going to shorten that up. I will save and exit, and there's your linking for center lines. Now, in Civil 3D, Matt, you may know when you create an alignment, you create a center line, you select it, and in the properties, it will say it's an alignment, it's a center line. Here, though, the CAD system only knows it as a polyline. CARLSON is the one that's keeping track of that being a center line also, okay? And of course, the beauty of having the centerline file is that I can come here and draw the centerline file, put a layer to go on, label the centerline, and I'll choose that file that we just have been working on, and there it is, drawn on a different layer and labeled accordingly. And again, it's still, when I select it, it's still just a polyline. And if I double click it, I go into the editor. So all of that stuff remains. Okay. Questions on the object linking from those settings? And those are the ones, again, they're not necessarily always right to have on, but you may want them to be that way because that's those are some of the results of having that linking on. Now, if you have these off, when you create these things and then go back and turn these on, the things you've created do not then become linked. It's whatever these are set to at the time you create that entity is how that's going to react. If you need that to then be linked and it wasn't when you created it, you need to erase it and recreate it. Okay? Questions on any of that? Everybody good? All right, so what we'll do next is I want to take a selection count too big for the grips, no problem. All right, so I want to take a look at, first of all, Matt, for you in particular, are you fairly comfortable in surface modeling, like creating a 10 or a surface? Say in Civil 3D, I mean.
In Civil 3D, I was fairly comfortable because, I mean, it just was, I mean, it would just go into the tool space and pretty much just create them all the time. But
right.
I'm a little less comfortable, yeah.
Yeah, but like you understood the concept of when and where to use break lines and how it uses points and it uses the vertices out of drawn geometry to create triangles. So I don't want to spend a lot of time on that part of it as part of the civil class. And Kayla, you'll get a really in-depth treatment of that in the fundamentals class. So for now, just sort of follow as we track some of this on. And here is, if you want to look at this in your off time, here's what we are talking about, or what we would be talking about in the fundamentals class is surfaces and contours or terrain modeling. Starts on page 18. And that is this discussion about using these points and break lines and such. Okay. So study that now if you wish, or wait until the next class that you take, and you'll get a little bit more in depth on that. I do want to talk about, though, a couple of techniques for adding some break lines that are slightly different with CARLSON that may help you out. And we're going to do that with this particular file. That's included with your data set. And you can see some of the pictures and some of the things that it goes. We're not going to do everything out of these exercises, but I do want to show you a couple of things to consider. So we're going to go back here, and I'm going to close off that file. I'm not going to save the changes. That was my class example 1. It's going to bring me back to my start menu, and I will open a file, and I'm going to look in my data sets folder, data sets for civil classes, where I was last. And I'm going to find this file called sample from T3 Global, and open that. And you should see something that looks like this. And we'll talk about this and some of the things to consider when you're taking prepared files for you. Although a lot of times you will be given a surface file already made. Other times you'll be given this base drawing that you need to make the file from. And that's a particular case. just depending on your workflows. So we'll talk about this in a few minutes. For right now, I'm going to, based on my excessive coffee consumption over the lunch hour, I'm going to need to call us a little break if you don't mind. So we'll take a break right now. Let's come back at 2:25 and pick this back up. And then if we need another little break later on in the afternoon, we'll take another quick one. So let's pop back at 2:25 and pick back up. Okay. So if you've loaded this up, you take a look at some of the things that are in it. This is an actual job created by an aerial mapping firm, and it would be normally delivered like this. If you go to the view menu, and let's choose freeze layer by pick, and then pick one of these white lines off on the side. And then if you see these sort of pink dots, those are some points. And you click each of those in turn and then hit enter to finish. I've now frozen off those layers, and this is what was typically delivered. This is a contour file, contour map, so here's a contour line with elevations. If you see down at the bottom of the screen, 1315, and this one should be 1314, which it is, okay. Let's escape to clear that selection. So it's now a file with the contours drawn and all these other things like these curb lines for the parking lot, which when they created the contour lines, they used these three-dimensional lines that were created for these edges of the curb edges. And then and you can see right here those arcs. Those are these individual segments. Now they put all of this line work back down to a zero elevation. Those white lines that we turned off, those were the ones that were drawn up at elevation that they used, along with all those little red points that we froze off. They used those two things to create this surface model. Everything else is just drawn to show you where it is in plan view. Now you can see that a number of ways. If you go to the view menu, look at your 3D view, and there's this command. We got two of them that we're going to be using a lot of: the drawing viewer and a surface file viewer. So if you look at the drawing viewer, and it's really the same viewer, the only difference is what you load into the viewer. The drawing viewer is going to ask you to select things from the drawing to view in the viewer. And the surface file viewer is going to ask you to select a saved surface file to load into the viewer. And you can mix and match those once you're in the viewer. We'll talk about those when we encounter those. But let's just choose the drawing viewer. It prompts us down at the bottom to select the entities for the scene. I'll just draw a window around everything, hit enter to finish my selection, and it will load up into my 3D viewer, which yours might be small like this. You can resize it just like any window. I just double click the title bar. You may also have the color set by elevation, where you'll see the spectrum and the different colors. Some people do that all the time. I don't particularly do that all the time. I do it sometimes to get an idea of, it's a nice little way of looking at this and seeing what the range of elevation is. And I can't really set that scaling, but it does give me an idea. I go from about 1282 up to 1339 in that range. So I know that I don't have some kind of stray data sitting at like negative 20,000 or something like that. Okay. So I'll turn that one back off. And I'm going to come down here and make sure I get this particular X, Y, and Z rotation button. That's the main icon to work the viewer. I'm going to go over into the middle of my view area, and I'm going to uh, click. If I'm in the middle, you see the cursor shape is an X and a Y. And if I go to the edges, it switches to be a Z. Now, it's not always exactly on the edge of the data. It's just sort of ish. Okay, so it's when it changes is when it changes behavior. So if I'm up here where it is still X, Y, and I'm in plan view, if I click and hold the left uh, button on the mouse and I push it up, pull it down, you can see how it rotates. And notice over here on the right hand side, I have that X, or I have the Y axis locked. So that keeps it from rocking back and forth. If I unlock it, you see it does go both ways. So I'm going to lock my Y axis. And this is a really good way to be able to position yourself anywhere you want to be, is you roll it back sort of almost flat, a nice oblique angle. Let the mouse button up, put it down at the bottom, and click and hold the left button and then spin it around left and right so you can line yourself up with certain features, and then use the wheel to zoom in and out just like you would in the CAD system, just by rolling the wheel. Now notice we're only looking at the contour lines, some spot elevations, and the contour labels. Now, why do you think that might be? I'm going to go back over here now and choose this XY where it says reset to plan view. I'm going to go back to plan view. But remember the setting that we had when in our general settings, we said ignore zero elevations. It also applies here, and I can toggle right here to ignore zero elevations. So if I uncheck that, it will show me the things at zero elevation. Now notice they're not lined up scaled because you're looking at a perspective view. These things up here are closer to your eye than the things down at zero. That's why it looks sort of flared out. And then you can sort of see, how that lines up over the top of each other. So there you can see, what was delivered is basically the contours and labels and spots are at elevation. Everything else is at zero. And then you can hit the little door icon, the lower right, and exit the viewer. Now, if we go back to the view menu and choose down here on this side thaw/on all layers, and we turn back on those layers that we froze the last time, and now we go to that same command, view, 3D view, drawing viewer, and we select everything. Now you're going to see the lines and the points. I'm going to click up here to ignore my zeros, but now you see I've got all of those lines and points that were used to generate the contours when they built that file. And that's a result of their photogrammetric efforts. They put the little floating point on the ground when they created those points, and they drew in these white lines. Those are break lines that they drew in. And here's those curb edges. See, we talked about those up here in this part of the world back when they were those purple ones that were just drawn down at the ground for convenience sake. And these that we would normally freeze off when we do our final drawing, but they're very important to use to help generate those contour lines. because that is actually something drawn at elevation. Okay? So if I take a look at this, that particular parking lot island right there, and I'll be able to sort of zoom myself into it like that. I'm going to go over here to the right, and on the settings tab now, I'm going to choose this button right here that says set the CAD view to that current view. I'll click that. It tells me my view is now set. I'll say okay, and I'm going to hit the exit button. And I may have to roll the wheel a little bit, but you see I'm still positioned at that same orientation. And now I can select this, and I can see that particular vertex down at the bottom of my screen is 1296.02, and that one is at 1295.7. So that's just above 1296. And if I look at this one, I would expect that to be 1296 contour. It is. If I look then at this line, there's my 1296.11. This one is 1295.91. So there's my 1296 contour where it crosses in between those 2 points. So that's all generated from that triangulation file that they created by having it draw a bunch of triangles in here, and it crosses each one of those lines and figures out, you know, where's that 1296, where's the 1295 over here, or sorry, 1297. I'm going back uphill. So this would be the 1295, and you see it climbs from there, and it climbs all the way up the face of that curve till it gets here, and then it backs off a little bit and goes over here in this direction. All right. So that's the sort of essence of what we need to stay aware of in 3 dimensions. And when we have a certain comfort level that we're going to get from not necessarily working in 3 dimensions out here in the CAD system, but I'm going to go back to my 3D view menu under the view menu, then 3D view, and I'm going to say plan view and let it go back. This is the way we normally work with our drawing files, is in plan view. But if I can be comfortable enough to say select a bunch of things that I'm verifying, and then come up here and use my 3D viewer to look at the things I selected to make sure that, okay, that looks good. Or if I see this has some kind of weird looking goofy point on it, I know I've got to fix something. Okay, so get comfortable with those tools, and it's this 3D viewer is incredibly powerful because you can add, go over the model tab, you can add surfaces and different things so you can compare multiple things that you're looking at. All right? Now, here is a very common thing that we do when we get files from other people. Matt, do you guys have your own survey crews?
Yeah.
And so most of what you work on as an engineer, they will have surveyed and prepared these base maps for you, correct?
Yeah, for the most part.
Okay. And then do they give you a surface file, or do you build those from their data?
Kind of depends project to project, but most of the time I'd say they provide a surface file.
Okay. So one of the things that you need to be aware of too is that when you're using somebody else's surface file, you need to look at that and verify it. So we're going to talk about some sort of QA/QC tools that we can use to verify some things. And another thing that's very common is that, particularly if you get files from outside survey companies, if you don't have your own crews, is that what you'll get from them is basically just a drawing with contours on it. Okay? You then have to take that drawing and, using these contours, make a surface file from that. Right? And that can be done, and there's techniques for it. But here's the problem. right here. I'm going to illustrate it right here in this area. If you build a surface from just these drawn contours and you don't have break lines in between it, remember triangles form between every vertex that it sits on. It seeks around itself and it tries to draw a line over to another adjacent or nearby point, whether it's a free point on the ground like these points over here on these little red points, or whether it's a point that's in this, say, drawn contour line. So I could be coming up here, sitting on this point, look down here to this point, and it draws an edge. Well, that one's perfectly fine. And then maybe it draws this edge, and then it goes up to that. Those are all good. But when I get up to here, I want it to draw the line down to here, and it might, that'd be okay. What I don't want to happen is for it to sit on that vertex and look across this gap and say, I'm going to draw that triangle edge over to that point, because we're saying it's going to go from from this elevation, which is 1337, and it's going to draw an edge over to this elevation, which is 1337, meaning that everywhere along that line, along that edge of that triangle, it's 1337. When I know that it's really 1337 up here and it's 1338 back here, so that should be like 1337.3 or 4 or something in there. So instead of it starting here and going up and coming back down, if I don't have that line right there in between it to prevent that triangle edge from forming, it's possibly going to do that. And that's going to put a whole bunch of these little flat triangles in these nose-shaped contours. And that's, you may see a setting when you're modeling this stuff called minimized flats. And that's what they're talking about doing. So it's a way, because sometimes all you get, and I'm going to freeze this off and these points. So sometimes all you get from a surveying company is this, say, drawn contour map. And when you build a surface from that, and we'll take a look at the two here as to what happens. And if you don't manually draw in these edges, these break lines, then you're going to wind up getting those flat triangles. And you'll see them a lot in ditches, along curb lines, crowns of roads, any of those kind of places. Like right through here, you can see another very sharp V-shaped areas, but you'll get triangles forming across here before they form down to here, and you don't want those to form. You want them to be blocked from jumping across the gap, and that's what that break line would be. So here's some techniques and some results of having them and not having them that we're going to go through. So for now, if you haven't already, I'm going to go to that view menu, and I'm going to freeze layer by pick, and I'm going to pick one of those white lines. If you see all those white break lines, I'm going to turn them off, and I'm going to turn off also, I'm going to pick one of those little red points that you see floating around out in the gaps and the spaces in between. Okay? And we're going to build a surface from this data, because this is sometimes all that we would get from a surveying company, or maybe even our in-house surveyors, and we need to see what's going to happen when we do that. Okay. So we're going to go to the, does everybody have, after the points menu, is your first menu called 3D data? Anybody have something different?
I don't see a 3D data point or 3D data tab.
Well, not the tabs, but the menus all the way up the top. File, edit, view, draw, inquiry, settings, points. What's the next one in yours?
Drill hole.
Oh, so you are actually in your geology or surface mining module. So go to the settings menu and choose Carlson menus and choose civil menu. So make sure you have this 3D data as the first menu. Okay, got that now?
3D data, yes.
Okay, so you are in the civil module. So like I said, that's how you can tell that what module you might be in. And it doesn't come up and tell you you're in civil. You just need to know that that's the civil module. If you're in survey, for instance, it has survey and COGO. If you're in geology, you'll see elevate, surface, takeoff, okay, that sort of stuff. So, so we're going to work in our civil menu now, or civil module. So let's go to the surface menu, and we're going to triangulate and contour. That is the basic command of creating surfaces. And there's all kinds of stuff that's contained in this. Some things that we can do in here automatically, some things we just need to be aware about. We're not going to go too deep into all of this stuff. That's really things that we really hit hard in the fundamentals class. So I'm going to basically have you set some of the same things that you see me setting here as well. So on the 4 tabs that are inside of this dialog box, I want you to hit the triangulate tab and uncheck the top 4 boxes, but check the right triangulation file box and then hit the select button that's off to the right of it. And this is the file to write, the one we're going to create, and we're going to call this one EG for existing ground dash from CTRS from contours, existing ground from contours. We'll save. And then it shows you down on the line below there what the tin file name is. And we're going to uncheck use inclusion and exclusion areas, and we're going to say shrink wrap perimeter reduction. Leave that to none for now. Erase previous contour entities is off for now. Again, you have your choice. But we want to ignore 0 elevations. All of these others are going to be left unchecked. We want our maximum edge length set to 2,000 feet on both interior and exterior. And let's uncheck densify break lines. And now you see right here, now Matt, this would be analogous to in Civil 3D when you go to create your surfaces where you can add contours. When you choose that option, it automatically knows to interpolate these ridges and valleys and minimize those flat triangles. Okay, Carlson just, to Carlson, this contour line, it doesn't care that it's a contour line. It reads its elevation and it's just data. It doesn't really differentiate between whether it's a break line or a contour line or an edge of asphalt or anything. It's just whatever data it gets is what it reads. And so if you're going to notice in this box, this is adjustments for source data of contours. So if you are creating your data from the contour lines, you would probably want to check that. But for now, let's leave it unchecked just so you can see what happens. And we'll also not simplify the surface. And let's look on the contour tab next and make sure it is unchecked to draw the contours. We already have some drawn contours, and we're going to see how they relate to the surface that we generate. Okay, so we'll leave it unchecked. But normally, when you're doing this stuff, and if you just have data and no drawn contours, you want to see those contours, so you would turn them on.
There are other commands that let you read an existing file and draw the contours, but we'll get to those later. So when you uncheck this draw contours, the labels tab is completely gray because we don't have any labels if we're not drawing them. Finally, on the selection tab, make sure you do not have any of those things checked, but this is a way to filter out the data that you are using beyond something like on the triangulate tab where we said ignore 0. So now, even though I'm going to select those 0 elevation drawn lines like those parking lot edges, it will ignore them because they're at 0. Okay. So on triangulate tab, we check to write the file, we give it a name, we check to ignore 0, we turn off the inclusion, exclusion, the shrink wrap reduction, and erase previous contours. Those are helpful later on. We'll learn how and when to use those. We set our maximums to 2000 and we leave everything else unchecked. We now say OK. And we read the prompts on the command line. It says, OK, select the points and the break lines to triangulate. So we're going to select all of the data that we have. And in this case, it's only going to be reading the contour lines because that's the only thing in here that now has elevation. So I have finished selecting. It tells me I've got 1056 and it comes back, select more entities. I'm through selecting, so I just hit enter or the right mouse button. And it's going to go through its machinations and it's going to tell you what it did. It read 9,280 points. It ignored 13,415 points with 0 elevations, inserted the points, inserted 9,280 points. Those are these up here. Right? It inserted 9,253 break line segments. Those are the line segments along each contour line in between those points. And then it said, warning, failed to insert 2 break lines. So 2 of those line segments somewhere in this mess had some errors. Okay, but didn't show us where they were, and they were such small errors, it did not flag the error box unless yours did come up. And then it says it's writing the file EG from CTRS.10. So that file has been created, and it's now part of our data set. I don't see a thing in our drawing here, but now we're going to take a look at it. So we're going to go back to our view menu, and we're going to go to our 3D view, and this time we're going to go to the drawing viewer. Excuse me, and we're going to select our information again. And when it comes up, you're going to see it's just the contour lines and the spot elevations. And we're going to also go to the model tab over on the right. And we'll close off this little layers thing, this box for layers. I don't need to worry about freezing and thawing layers. And I'm going to select surfaces, and I'm going to either right click and choose add surface or choose this button, add surface. And I'm going to add that surface, and there's the outline of it. I'll choose this EG from contour. You see it's in my recent files box. I'll say open, and it's going to pop into place here. Now it's either going to look like that or it's going to look like that when you see it. Okay. So if you see like this and it's not colored in, because those are surface triangles, they are considered solid. So this button right here toggles whether that surface data gets shaded or not. If I click it back on, you see it on and off, it changes that color. And it sets, now this comes in, it comes in the first time as red for whatever reason. And usually what you have to do is go to the view tab and just toggle this off and then back on. But you can also go to the model tab, open up the surface file, select that file, and choose surface properties, and you can change the color. You can even assign a texture to it, like grass or asphalt or something like that. So anyway, here's our surface. And you can see that in certain areas, the contours line up pretty nicely with the surface. But look at places like this. See that crease in the surface right in there? And if I spin that up a little bit, you can maybe see what had happened. So you see this right in here is an example of, let me see a place where we've got some of these flat contours or flat triangles. There's a triangle that is flat. If I go back here, let me change my shading a little bit so you can see a little better. All right, can you see this triangle right in here? These things. That's saying that that's all one elevation across in there, but yet and same thing up here. But we
Yeah,
know. I'm sorry. Go ahead, Kayla.
I was saying yes, they are visible.
Oh, yeah, okay. So, but we know that the elevation, say right here, is not this. It's not constant from here across to here. It's actually a little bit higher. It goes from here down to here, down to here, down to here. But because we didn't have any line work drawn in there, it created those as being flat. And we also look at over here, say on the edges of the road, look at what a mess it made out of those road edges. See that? So, even though it's, and here you can see all of these little flats. Now, what happens if you run a profile down that line? Do you get the nice, even, continuously sloping line, or it's going to look like a set of stair steps, right? It's going to go flat, drop, flat, drop, flat, drop, flat, drop. Okay. So those are the kinds of things you want to avoid depending on what you're doing. I'll talk about that in just a second. And let's look over here for a minute as well. Here's an area of some known problems. Right in here, this happens to be, along this feature, that's supposed to be a loading dock. So that should be a nice, nearly vertical surface. You see, obviously it kicked out. Now look at this right here. It actually looks like a, it looks like a ramp almost to come up there. That is not there. Those triangles, the contours rather, were broken off and not displayed because they were getting too tight. So that's a case of where we need to put in some additional controls. And we can do that several ways. Right, so we can either draw them into the data and go back and rebuild the surface, or I'm going to exit this and back to our drawing, and instead of using that drawing file, I'm going to load the surface file instead. So view, 3D view, instead of drawing viewer, the surface file viewer. And I'm going to choose this file. And if you load the file instead of the drawing, you're going to see, potentially you can see, I'll go to my settings. Right now I said show the contours, and you can change that contours to whatever interval. I'll match the interval we had in our source, 1 foot. You can display the triangle edges or not if I turn those off. Now this represents the contours that it would have drawn if we had said draw the contours. And right here's that area where it's not drawn correctly. Now, if I show the triangle edges, you can see those triangles that formed. And you can also see that if I go back here and turn the filling off. Okay. So if I don't fill in my settings, or if I turn on my triangle edges And this set colors button, by the way, lets you control what those colors are. Now, you can, and a lot of people do this, you can edit this surface file right in this viewer and fix some of those conditions. And you do that by going back to the View Control tab and choose the arrow icon. And now these commands down here are edits that you can make to the tin. So if I add a break line, and I chose that as my choice, and I'm going to double click at this point down here, it identifies that point and it wants to know where do I want the other end of my break line. Well, I'll double click over here to this point. And when I do that, did you see what happened? It took that ramp out. I can do the same thing from this point to this point, and it took that out, this point to this point. Okay. So I could even go, say, from this point. We'll see if it's going to let me. Sometimes it will. All right, so if I go from this point, I'm going to go all the way over to this point. All right, so it's not able to because of some of the, let's see if I can undo this. All right, now if I go from here to here, it's still not quite able, but you can, you don't have to do it segment by segment. There's something in there somewhere in the definition that is causing it to not be able to do that. But anyway, you saw the results of doing this particular exit there. I took out a lot of them. Now I can go from here, say, to here. That's probably not going to let me. All right, so from here. All right, so anyway, there's something in there somewhere that's keeping that from happening. There, it fixed it that way. All right, so I could do something like that, and then see how those contours are radically different than what we started with. Okay, and that's really more like what they should have been. But I needed to know that those were break lines, okay, when I look at this data. So if you have some data that's like this, now I'm going to exit and it's going to prompt me to save the edits. I'm going to say no, just so I've got that same focus. And I want to, let's see, I want to, is this blue line? Okay, that is a drawn polyline. There we go. Now, this will illustrate also that same business of those flats. So if I go to my profiles menu and do a quick profile, I'm going to choose my source of surface model to be a file, and I can look at 2 files at a time. I'm only looking at one right now. I'm going to say the second, and I'm going to hit cancel. I'm only going to look at the one. So when I choose second and then choose cancel, it clears that out. And I'm going to say first, and I'm going to find that one we just made, e.g. from contours. I say okay. Now it's just pick a starting point or choose a center line or choose P for polyline. If I say P for polyline, and I'm going to select that line that's drawn right down the feature. Okay, so there's my line, and I'm actually, because the direction of that polyline was backwards from what I was using. But you see that profile? It looks like a bunch of stair steps, right? Because I'm going flat, drop, flat, drop. And if I zoom in pretty tight in here and then watch when I'm in this flat area down in the bottom, see where I am? I'm inside the nose point of that contour. And then I get up to here and it starts to then pick up. And climbs up a little bit until it hits that flat area again. And again, you have to sort of keep looking between the top and bottom views. All right. So as you can see, this would not be a very good surface to use if I'm trying to say, figure out where I want to put my my inlets to catch my drainage, because this is just a mess, right? And it's not representative of what's really out there. Now, here's something to keep in mind. If you may have noticed or not, when I said sometimes you need to manually put in these polylines, excuse me. Depending on what you're trying to do. So I said that purposefully because in the case of, let's say I'm designing, where I'm going to build things, where I'm going to put curb inlets, where I'm going, if I'm building this surface to try to go out there and use machine control guidance, or even if I'm going to just stake out this surface, this would be horrible. It would not work. It was not very accurate. However, if what I'm doing is comparing this surface to, say, the original existing ground, or this is my existing ground and I'm going to do something else with it, and I'm looking at volumes, and I'm comparing volumes between these surfaces, it's less critical when I'm doing volumetric analysis than when I'm doing qualitative analysis. And for this reason, if you look at this profile, I'm going to go over here and select the draw button, and I'll just take the default. I don't know if it's going to be exaggerated or not. Let's take a look at it over here. I'll just plop it down there. Okay, it wasn't all that exaggerated. I'm going to try this again, just real quick. I'm going to go to Profiles, Quick Profile. Same deal. P for polyline. I will select that polyline. Now I'm going to draw that. This time I'm going to set the scale in here. So I'm at a 20 scale. Let's make that 2. So I have a 10 time vertical exaggeration. This will help illustrate the point better. It's going to be like so. All right, so there's that little piece of ground. Now, if I were to do this properly, I should see something that looks more like this. Well, actually, not that. It should be more like this. And I should set my object snap to be midpoint. All right, so there's really what that profile should be looking like, okay, if I walk down that line and if it were modeled correctly. So what happens if I compute the volume of this surface compared to another surface above or below it? When I do that, I'm going to have some areas like right in here where I'm too low on my surface, but I'm going to have other areas like right in here or right in here or up in here where I am too high on what it's supposed to be. So on average, over a large enough sample size, those overages and underages, if you will, the overshoots and the undershoots, they tend to balance themselves out. So you would come up with volume comparisons to be fairly consistent with the same numbers you get if you were to generate this red surface instead of the blue surface on both of the two surfaces that you were comparing. Where you would find problems would be like this ramp over here. That, remember, we had that big giant ramp that stuck out here. Now that's an area of excess surface that's not really counterbalanced somewhere else. So again, depending on what you're doing, what you're trying to do, will depend on whether you need to take the effort to create those break lines or not. So here's a couple of really good ways to create those break lines, particularly when, if you've got these drawn contours, you've got all these drawn lines, but they're drawn down at 0, but you need them to be elevated to where they cross these lines. So if they're already drawn, here's how you can do that. And even if they're not, I'll show you where we can draw them in ourselves manually. But if it's already drawn, and even if it's at 0 elevation, we have this 3D data menu. This is your friend, get to know it. And we're going to go to the 2D to 3D polyline command. And we're going to say by screen entities. And what that does is it takes that 2D line that we choose and it looks at all of the chosen 3D elements that it crosses, and it sets the elevation along this new feature it's going to create to that same elevation. So let's choose that command, 2D to 3D polyline by screen entities, and let's read our prompts. And it says first to select the polylines to converge, and we're going to say select entities. So we're going to pick, I'm going to pick this one. And again, I'm down here in this lower left. So I'm going to pick that one, this one, this one, this one. And then I'm going to also pick these two. Those are my curb lines. And let's pick a couple more. Let's pick this one. And let's pick this one and say these two. And I'm just crossing to the left as my selection. And let's choose this one. It's a fence. That's really probably not the right one to use. All right, so I don't want to use that one. So one of my techniques to select, Kaylee, is if I keep adding to my selection, if I type the letter R, that lets me remove or subtract entities from my selection set. I now have 11. So I'm going to click that one. I didn't want to use it. That's a fence. It's not really necessarily representative. And now it's still in subtract mode, so I have to say A to add. So now I'm back to this. Let's choose another one here. Let's say this one. And where does that go? It just goes up to there. And then we'll come over to this edge and choose that. Oops, sorry. That one. Can't seem to catch it. There we go. That's all I will choose that one. Then notice there's not one down the middle of this with these already drawn polylines. And I will now take, let's grab one of these islands here as well. And so now what this is going to do is it's going to read this as a 2D polyline. It's going to hit this contour line and set the elevation right there. And it's going to come all the way around here until it hits this point. and set the elevation there. Now, what is that going to do to that island, do you think, in terms of elevations? What's the elevation of this line? Is, you know, whatever that contour elevation is, right? So it's going to set it right there. And then as it walks around, it's going to encounter it again over here on this other side and set the elevation there. And those are the only 2 points it knows. So that's going to be set to that elevation. And the same thing's going to happen to this one in the middle. It's going to set the elevation to that elevation right there, and again right there. Now that's not really accurate. It's supposed to be about half a foot higher than the one out here. But this is the limitation of doing this in this particular way, if that's all the information we have. But we'll take a look at that in a minute. So we're going to say, okay, we'll finish our selection set. Let's take the default for the tolerance to extend gaps. And now it wants us to select anything in the surface that are 3D faces, lines, and polylines. I'm just going to type all. So it's going to consider everything that it sees with elevation. And I'm through selecting those, and I'll say enter. And then one more thing, see, it noticed that it ignored 269 of those because they were at 0. Do I want to keep the existing polylines? I'm going to say yes. And it wants to know the layer for 3D polylines. Well, I'm going to put that on a layer. I'm just going to give it my initials. Okay, just so I know exactly where those go. And I'll say okay. And off it goes, and it creates those. Now that layer called KAC is obviously yellow, and they are drawn at the elevation where those things cross. If I were to select these elements in my viewer and zoom this up, I can see that those yellow lines were in fact elevated to the elevation of those things that they crossed. Let's see if I can't illustrate this phenomenon right here. I go over here to the right hand view control tab, and I'm going to set my vertical scale up pretty high to 5. All right, so I'm going to have a 5-time vertical exaggeration. And if I look at those 2 lines right there, I see they are exactly the same elevation, and yet intuitively I know they're not. One is supposed to be higher than the other. Okay. So I'll pull that back down to 1. But everything else is fairly close. Now look at this right here, and I see that this is the edge of asphalt that runs down somewhere else. But there's also another little, see that little valley that runs right there? There should be a line that runs down there. And in fact, there is. Remember those white lines that we froze when we first started doing this? Those are the actual break lines, and they are there. But let's just take a look at what we've done with this part so far. And we're going to make another file, another breakline file, or another surface file. Now remember, and you don't have to do this, I'm going to just show it to you. If I look at the original file that we drew, or that we created, and I'm going to turn this fill-in part off. You see all of these, let's turn the contours off too. You see all these triangles over here? They are actually invalid triangles. I don't have any data over there, but because I did not put any kind of a boundary around it, when it's sitting on those points, it's looking all around themselves for other points. And so it looks back here and it sees those points. So it starts drawing these lines in there, and it draws them up to the maximum distance that we said we would accept, which was 2,000 feet. Now I'll show you what we're going to do with that on this next one. I'm going to do to counteract that. And go back here to my view control tab and turn our solid back on. I will display my contours again, and I'm going to exit. Okay, so let's make a second surface to compare. Go to the surface menu, triangulate and contour. And this time we're going to keep everything sort of like it was, but we're going to make a few changes here. We're going to leave the contour labels and selection tab alone, but on triangulate where it said write the file, I'm going to hit select to give it a new file name. Otherwise it would prompt me to overwrite. So I'm going to say EG dash from CTRS and view BRKLNS. So existing ground from contours and a few break lines, whatever you want to call it. You can call it surface 2, I don't care. All right, so just give it a name that's different. And this time we are going to say shrink wrap perimeter reduction. And we're going to change that to, from none, we're going to set it to medium. And we're going to choose the setup button next to it. And I want to see what it looks like. I'm going to draw it as a 2D polyline on this layer, see topo boundary, and say OK. So you can see what happens when that gets drawn. Again, still ignore zeros. That should work. I'm going to say OK. Now it says select the points and break lines to triangulate. So I'm going to grab my data and I'll say enter. And now it's going to find some errors because it's run into some places where I've got these particular error conditions. I can have one of 3 conditions. I can have T intersections, and that's where a line goes up to join another line. When you're looking at it in plan view, it looks like a T intersection, so they don't cross, it just goes up to the edge. But they are at differing elevations. So there's one point, but it doesn't know which elevation to use. The other type is similar to that, but it does go ahead and cross it, and it's called a crossing break line, in which case 2 3-dimensional lines actually cross over each other, but at differing elevations, so it doesn't know which one to use. Now, it will make a decision. If you just say exit, it will go ahead and use this data, making its own decision for you. But once you have this box that comes up, you've got some ways of finding what these are. Right in here, you've got a number in parentheses. That's the amount of vertical difference. So you might look at this one that says 0.014 and say, well, I can live with that. Right? But to investigate these, I've got this T intersection here. I've selected it, and I'm going to say zoom to, so it puts it in the center of the screen, and then I'm going to repeatedly hit this zoom in, and I'm going to see right in there is where it sort of, for whatever reason, didn't set that elevation correctly. So you could mark that spot and change it, or even while you're here, you can look at it and see, if I see that polyline, see that elevation is 1318. Okay, and if I look at this polyline, my mouse will come back. And I see that that is at 1319, so those look to be the same. Something about it that's flagging that difference. It says it's a T intersection, so there is there are actually three things there. This one V road outline, that's, if I look at that, the polyline, no, it's still it's set at 0 elevation. So I'm not really sure exactly what that happens. But anyway, as you go through these particular locations, you can see where it generates some differences. No, you really shouldn't be doing that. Now here's a case on this vertical edge that's 2.5 feet out of whack, and that's sort of bad. And that's because that line might have found something. So that's at 1952, that's at 1960, that's at 20. I don't see that that's a problem. There's probably something somewhere in there. Let's see if I can't find it. There's something in there that was non-zero. But in any case, so anyway, you would find these errors and clean them up as you go through it. For right now, I'm going to go ahead and say exit and let it just use its own and make its own decisions. But we're going to show you the difference in the two surfaces now. And we can use these in two different ways. Remember, and now I'm going to freeze that this layer of KAC here for a minute. I'm going to select this boundary, see topo boundary, and I'm going to choose the command to make that layer current. Let's see if I can pull that from the view menu, set current layer, and I'll just pick that one just for yucks. And now I'm going to freeze. Let's do it another method. I'll just go to my layer control, which I can also get from the view menu or the layer toolbar. And I'll find that KAC and I'm going to freeze that off. So those 3D lines are now off. I'm back to the 2D line. And let's look at that same profile that we had earlier with the stair steps. And I'm going to go to profiles, quick profile, and this surface file. And this time I'm going to choose existing ground from contours, and we're going to compare it to the other one that we made. Now, the first file that we choose is going to be the one that we're going to read. So I'm going to use from contours and a few break lines. And the second file will be existing ground from contours. And I'll say, okay. I'll type P for polyline to answer my prompt. And I will pick that cyan colored polyline. And now you see that difference. And as I track, you see that white line, that's my more correctly prepared surface. So I've missed all of those flattened off areas of my surface. So I've modeled the surface a lot more correctly in there. Okay, so you see how that works. I'll hit exit for that. And let's look at it also another way, is if I just I'm going to do a selection. I'm going to, with no command active, I'm just going to click and drag to the left to select these few things. Maybe I'll get a few of these as well. And I'm going to go to the view menu, 3D view, drawing viewer. And I'm just going to look at that particular area. And I'm going to go to the model tab. And I'm going to add both of those surfaces one at a time. So the first one will be my original one that I did, e.g. from contours. And I'm going to hit add surface again and choose the next surface and open that one. So now I've got two. I'm going to go back to my view tab and I'm going to turn this off and then back on so I can see the differences in those two surfaces. So my first surface is the green one. Remember, it had all those triangles out there as well. And my second surface is the yellowish looking one. And I can go over here, open up my surfaces, and I can just double click each one and turn them on and off. So now here's my second one. You see how nice and creased that area is. And if I double click the first one back on, the second one off, there's those stair steps. Okay. Oops, sorry, meant to do that. So there you can see, and here again, you can also see right in here, it's pretty extreme that I've got the curb line is now, at least as far as where the road comes down to the curb and then goes up to the top of the curb, pretty well modeled. I still have all that stair-steppy looking stuff behind the curb because I did not elevate that back line. But you can see all of these places where I did elevate those drawn curb lines, you can see them show up as nice sharp edges. And you can see where I didn't, I still have all of those sort of free forming. There's that ramp over there again. Okay. So these would be areas that you would need, and you can also see right in here, see those still have those flats across those nose-shaped contours there. So there still would be some work to do to model that exactly correctly. Now, I'll explain about what happens with this. This is my boundary. And I'm going to go to my layer manager, choose that C-topo boundary. I'll make it red and I'll make it so that you can actually see it. And turn on my line weights. All right, so there is the resulting shrink wrap boundary, and it is so called because it took a look at all of the data that I selected and it did what's called a shrink wrap, and it drew a boundary around it based on that reduction factor that I set from none to medium. And I'll show you what this is actually doing. I'm going to select that and choose delete. Let's take a look at it individually because you can draw those individually. And I generally do this myself individually first. So I'll do a shrink wrap entities. I've got it for that same layer. I've got two methods, across gaps or look at bounded line work only. In this case, because I'm going from end to end to end, I'm going to say across gaps. I will make it a 2D polyline, give it a maximum gap that you want it to consider. And perimeter reduction, right now, again, none, low, medium, high. Let's say none and say okay. And then I'm going to select all of our data and now watch what happens. That's the perimeter of all of that data with no reduction on the outside. And what that means is it has, if you look back here at this command set, when I did shrink wrap polylines, select the line work, which we did, and then it said, okay, reading points. I inserted 10,000 break line segments, 22,740 points, this many break line segments, and then it had a couple of break lines it didn't use. found crossing break lines, and then one triangulation line that exceeded the maximum length. Now, all of those messages are telling you or telling the user that it was doing something as you were when you ran the command. And what it was saying is that you selected this when you run that command. Oh, come on, sorry about that. This is sticking. Sorry, can you guys hear that? I said, oh, good gracious. It read that. It read all that text to me. I don't know if you heard it or not. I think it only came in my earphones, but anyway. So what it's saying is that it's actually triangulating all of that data, and it's doing so that it generates triangles, and then it's going to reduce the triangles that are formed around the perimeter based on that setting. So here it is with none. And if I do the command again, draw shrink wrap polylines or shrink wrap entities across gaps, but this time instead of none, let's crank it all the way up to high, and we'll say okay. We're going to select everything here except for that one line. So that's all selected, and I'm going to type R to remove and choose that line and say enter. And now there's that version. So it found data. I'm going to change its color just to differentiate. We'll make that one yellow. So that one went, from across the end of this line to that line. So that part looks pretty good. So and it goes out here, but see, there's a point out here. If I take a window around that, it's actually it's a little bit of a polyline, sort of just a stray polyline that is V-side structure. All right, so that's probably, and that has an elevation of 0, so that would be something that I'm just going to erase that. So I would normally just, in this case, I'm going to just hover and remove vertex, hover, remove vertex. So that puts that back down there. All right, so now this had a high reduction, but you see when it gets up here, it gets to the end of that line. It doesn't see any more data till it gets over to here, but it sees this data, so it jumps down here and starts doing this. So you probably would find a good say a compromise to, instead of using high reduction, let's do another one now to be, and if I change my current layer to green, I don't know if it'll honor that or not, but we'll say draw shrink wrap entities, and this time, oops, hit it too quickly, draw shrink wrap entities. I'm going to change it from high to either low or medium. Let's just go to low. We'll say, okay, we'll draw everything around this except we're going to remove. So R, enter. I'll remove that line and that line. And we'll see what draws there. No, it didn't honor that, but I'll change that to be green now. Right. So now this one, you see, is not quite so convoluted as the yellow one. So it didn't reduce it quite as much. A little bit over here. But it's not, all the way around here. So, and now keep in mind, when we do this and use this as a boundary for our surface, it's going to clip our surface at those margins. So I wouldn't really want to use that. That's what was used when we said none when we ran the command. So that's why all of those triangles got built out here. And if we were to draw contours, you'd see the contours out there. This one, however, the yellow one, is a little too convoluted. I may still want it to interpolate some data in some of these places, just maybe not quite so much as that. You know, like right in here, jumping in and there. I may want to have it go from here across to here instead of in here. All right. So you would find sort of a happy medium as to which of these levels that you might want to use. And in general, I found that either medium or low gives a good result. And here's something else you can do. Right here is this section here that I really kind of want it to jump in here. Well, if I select that, remember, it's just a polyline. I look over here at my properties, I see it's a polyline. So I'm going to hover the mouse right here on this segment. I'm going to say convert that to an arc, and I'm going to sort of just draw that up like so. And then that would be where it clips my surface. And not only that, but I can also, if I so choose, turn my snaps off. If I just want to turn my selection segment off. So if I wanted to, instead of even running the command to shrink wrap entities, I can just manually draw a polyline and use that as a boundary. Let's make that, keep it blue, or give it a nice heavy line weight so you can see it. So no matter how I do it, however I come up with this polyline, in which case you can make edits to it after the fact, or you don't even have to create it using shrink wrap. And we'll convert that to an arc, we'll use that. And now, if we were to say surface, triangulate, and contour, right here was this shrink wrap perimeter reduction. None, low, medium, and high. And that would generate these, just like we did this manually. But if you already have it drawn, you would say, instead of that, you would say use inclusion, exclusion areas. And then how do you want to set the boundary? You want to trim the edges at that boundary, or you could remove any edges that stick over it. Well, we're going to just trim it. So it's going to trim it right along those edges. And let's say, I'm going to choose that same file name, just put a 2 on it. I'll say OK. And I'll select everything. Now remember, those are 2D, so they have 0 elevation, so it's not going to, oops, I see what's happening. I'm glad it did. You saw those errors come up that said inclusion polylines not closed because, and this is the key takeaway here, when you run that command, triangulate and contour, when I chose to use inclusion exclusion areas, I say, okay, read the prompts. Notice it says not selecting the data to model, but select the inclusion perimeter. All right, so now I'm going to use that blue polyline. And I can have more than one. So I could just do pockets of modeling so it doesn't have stuff in between. I could work down here and work up here and be done. And now it wants me to, after I hit enter to finish, it says select exclusion. Well, let's do a couple of these exclusions. Now, why you might ask, am I selecting these? Well, these are building footprints, and I don't really know what's going on with my surface under that ground. Or sometimes you could just use them and it puts like a flat pad. But if you're not sure, maybe there's a pond or something in the way, you could set those as exclusions. And I'll say enter for that. And now it says to select the points and break lines you want to triangulate. I'll grab everything and go. Okay, so now if I look at that surface in contrast, if you remember what it used to look like, there's that there's that one from contours and a few break lines. And here's our new one. Notice the difference now. And you can see the edges are, there's that arc that I put in, there's that drawn polyline that I drew, and those are the holes or the exclusions that I created in that surface. Okay? Now what that means when you have a hole in your surface is that when you compute volumes and you've got a place where there's a hole, it simply does not do the computation within that spot. Okay. So just a few things to keep in mind. Again, you don't want all these triangles out here. It won't hurt anything as long as you are aware when you do calculations that they may or may not have some effect. But it's typically good practice to go ahead and give it a boundary and select that boundary. Now, all of that being said, let's select all of those drawn lines, and I want to get rid of those, and we're going to go and do this the right way with this data set so you can see the difference. So I want to erase all of these lines. You can pick them individually. Here's another tool for you. Go to the edit menu and choose erase by layer. Okay, remember the layer we chose, we could select it called See Topo Boundary, or we could select it from the screen. We just need to pick one sample, and it finds everything on this layer or just these certain things on that layer. I'll say all on that layer. I'll say OK, and they all go away. Now this one did not go away because it's on layer 0. That's one I drew manually. I'm going to also select it and just hit my delete command. I will now also change to be, my current color is now back to by layer. All right. Now, remember I told you that you could take those drawn lines and elevate them with that 2D to 3D by screen entities. And here's another thing you could do, is you could draw a 3D polyline. So if I draw a 3D polyline and let's prompt for the elevation of slope, and I'm going to say okay, and I'm going to try to put this break line down through these points along my contours. So I'm going to turn my object snapping back on with my endpoint snap, and I'm going to go from that endpoint, and it reads the elevation of 1296. I'll hit enter to confirm. Enter to confirm. I'm going to go to that one, hit enter to confirm. I'll go to that one, hit enter to confirm. So you get the idea. I'm doing all of this as I go down the line. Now, what happens right here is that really should be more out, I should have some intermediate points out in there, correct? So if I type U to undo that segment, I could do this. I could pick a point here sort of in the middle, and now notice it reads the elevation down there on the command line of 0. But one of the things that I could do is, because it's 0, it's thinking that I want to interpolate, which is what I want to do. So that's one of my options, next point, or type in an elevation, or interpolate. So I'm going to I to interpolate. And so now it's going to interpolate until I get down to that elevation, right there, and now it read the elevation and will be imported upon completion. So I'll hit enter there, interpolate. And now it reads that elevation. Okay, so you can do all that kind of stuff and sort of work your way around it. And it's sort of tedious when you have to sort of keep track of all those things. So here's the faster way of doing that is first draw it as a 2D. When you draw a 2D polyline, I'll just set this back to by layer, use the current settings, and I'm going to go from endpoint to endpoint. And now I've got some arcs to put in there, so I'm just going to do that, but I know I need to do some changes in here. So I'm actually going to select that. That's about right. Right in here, I want to add a couple of things. So I'm going to hover the mouse and add a vertex, say, sorry, my mouse is lagging here. So I'm going to pick a point in there. I'm going to do another one, add a vertex sort of in here. Okay, so that sort of does those things as individual segments. Or if I hover the mouse and convert to arc, I can put in a nice smooth arc. Remember, that's going to, when it converts it, remember, it's going to use one of those methods that we saw in our settings. So this could be, this could be the way that you're sort of modeling the bottom of that ditch line or whatever that happens to be. Okay, now you have a 2D polyline still. It is at 0 elevation. And now we're right back to where we were to go to our 3D data menu, 2D to 3D polyline by screen entities. We select the one we're going to change, and then we change, we tell it the things we want it to consider, and keep existing, no I won't, and set layer name now, we'll just keep it there. And now this is a 3D polyline, and there's all those little line segments along the arc, and you can see that it is now set elevation everywhere it crossed those contours. So that is another way of doing that stuff. Now, is it tedious? Yes, sure it's tedious. And sometimes I've done, in particular when I was doing landfill work years ago, and these are for, 5,000 to 6,000 acre landfills, all we would get were these contour lines, and we would have to go through and model at least the major drainage ways and ridge lines. So it took a lot of that kind of stuff, but that was before we had tools like 2D to 3D. We had to actually snap, point to point to point to point with all those elevations and be really careful to make sure we didn't miss one and set a 0 elevation inadvertently. So it was, really tough. Now, with that, if that's all you have, then the you're forced to do that when and where you feel that you need to. Again, like if you're modeling this to construct it or to put in culverts, you want those to be nice and smooth. If you're just doing this for rough earthwork numbers so you can compute a bid estimate because you're going to do the excavation on the project, then you wouldn't really necessarily care. You just want a good rough number. So again, keep in mind what you're doing with it and work from those, from that premise. Okay. So the last thing now is to be aware of what actually got delivered. And let's go back to the view menu and let's thaw/on all layers. And here's another little technique to identify some things in the drawing. I've got these yellow, that was my KAC layer. So I'm going to go back to edit, erase by layer. And this time I already had that layer. I'm just going to, I'll clear that. I'm going to select from screen. I'll get that KAC layer and say, okay, so now I'm back to what I had delivered. So my aerial mapping company was kind enough to give me all of the data that they used to generate their contours. Okay. And you see that they had data way outside where they trimmed their contours off. That's also good practice when you're generating this stuff, is that they've got data out here, but they know because it's on the periphery that you're going to have some potential problems. They just came in about, I don't know, 25, 50 feet, whatever that is, and trimmed everything out. And but they took all this from aerial photogrammetry and generated all of these lines that are at 3 dimensions and all of these different points, like this mouse lag is silly. See these different those points that you can see there. Those are things that are right down on the ground in their model. And so they're using all of that stuff to create that surface. But yet they're going to give us all of this data so we can reconstruct the same data they use to construct their contour lines with. Because some clients may only want to see the contours. Some clients, though, if they're going to work with it, they need that surface information. Now, this particular project, they actually also delivered the surface model, but we don't have it. This is what you have to do if you're building your data from delivered information. So what we're going to do next is build a model from this data. However, if we were to take everything like we used the contours before, it would use those, but it would also use not just the contours, but also these lines where they cross. Now, some of these contours might have been smoothed, so they may not be in exactly the same places. Here's another example of this little island. Remember, that was all the same elevation. And now you can see, they're not the same elevation. This one varies from, if you take a look at this one, and this contour is, what is that elevation? 1314. So if I look at this polyline, and let's step through this, keep an eye down here on the vertex Z. So that's 1436, 35, 33. So it keeps coming around till it hits. All right, so there's 1408, and the next place it got was 1391. So what was that contour that we said? Was it 13, 14? So 1408 to 1396. So the 14 elevation crosses right where that contour line crosses. And it keeps coming around. You notice the elevation keeps changing until it gets back around here. Now starts to come back. And so right in there, I'm at 13.96, almost 1314. I go up there, now I'm above it at 1425. So this is actually a changing set of elevations, and the contour line crosses it right where it's supposed to. And if I look at this corresponding element, and if I hover the mouse right in that one, I look down at my status line, I see that's 1313.96. If I look up here, I'm at 1314.46. So I'm half a foot higher than down here. So that's the actual real life three-dimensional representation of that structure. Okay. So this means that I'm going to get the best model I'm going to get if I use that data they gave us. And I'm going to use only that data. I'm not going to use the contour lines because I'm going to get a lot of conflicts. So I'm going to take a look at just those elements and these points, which they will also be in there. And I'm going to show you the difference here. I'm going to draw a little rectangle from here up to here. And I'm going to show you some differences. So if I were to draw surface, I'm going to go to the surface menu. I'm going to draw a surface. I'm going to come down here to the bottom. And I want to draw the triangular mesh. I want to draw the triangles resulting from either one of these files that we used before. Let's go ahead and just choose this original. And we'll say open. And I'll just draw them as lines. And we'll use inclusion and exclusion. Then we'll do it all over. And use 10 colors now. We'll say okay. The inclusion parameter, I'm just going to do it within this area here. And so I'm just going to do within that area, no exclusions. And now, all right, so now you see where these happened. And they were, if I were to isolate those contour lines, I would see where they go. I'm going to, in fact, select all of these and put them in the back. And now, if I look at this contour line and this contour line, and let's say this contour line, this contour line, now look at where the corners of these triangles fall. The only things I have selected are the contour lines. Okay. But you see that the triangles go to where the vertices of those contour lines are. So here's this contour line that runs up through here. And so every vertex along that line forms the corner of a triangle. So keep that part in mind. Same thing up here. If I select that one and select this one, now you see where the triangles form. Okay, they all go to all of those places. I'm going to go back to erase, edit, erase by layer. Clear that again. Select layer from the screen. I'll just select those triangles. It's okay. All right, so that showed you where those are. Now, when I use this data, you're going to see the triangles form. You know, as long as I'm using those data, I should expect to see triangles form on there, and we'll, we'll look at those in a minute. But we're also going to only use elements from this layer, which is the V topo break line layer, and escape and select a point, a layer called V topo DTNP, which stands for topography, I'm not sure the DT, but MP stands for mass points that they use. So I've got points, and I guess it's digital terrain mass points. So I'm going to use break lines and points to generate this surface, even though my contours, and remember the contours are just an output of that surface. So let's do that. And we're going to do that by isolating only those two layers. We'll go to the view menu and we're going to isolate layers. And we're going to pick one example, which is that white line there, and then pick the other example, which is that little pink dot. I now have two things in my selection set. That's all I need. I hit enter, and now there's my data that I'm going to model. So now, back to surface, triangulate and contour. I will make sure I write the triangulation file. I'm going to hit the select button, and this time I'm going to call this EG dash from break lines and points. I will uncheck use inclusion and exclusion areas because I no longer have that drawn, but I will let it shrink wrap, and I'll just take a medium, oh, it doesn't matter. Let's take a medium reduction. I'm going to go to the setup button and I'm going to uncheck to draw it. I'm just going to accept it, whatever it gives me. Leave these the same. Densifying break lines are a case for when you have these drawn lines that the points on them might be way far apart and you need a little bit more densification. You need more points along them to give you a few more triangles. So I'm going to turn that back on and I'm going to set that interval up to say 25 feet, every 25 feet. Now it may not add any, but if it does, it makes sure that my triangle corners are at least 25 feet within the next one. And now I no longer have to worry about minimizing flat or interpolating ridges and valleys. And again, those are things that you can use if all you have are triangles and or contours, and you don't have time to draw those break lines in. You can do that and it will help. It's far from foolproof, but it will help. Okay? So I'm going to do this. Everything's there. And while I'm at it, well, no, we'll leave the contouring off for now. And we'll draw those in just a minute and compare them to the ones they delivered. I'll now say OK. And it says select the points and line break lines to triangulate. Again, select everything with a crossing window. I've got a couple of errors here, and they happen to be a little head wall that had some crossing problems. Oops. That they got in a hurry when they did their modeling. So that's 13,1366. This one is 13,1371. So that's the high part. So there is 93 and there is 63. So that's the high part. That was 13, 13, 13. So that's high, high, high. So this one probably should be a little bit lower than that. But anyway, we'll fix those particular errors there. We've got a couple of other places in here where the edge of the road comes down and meets the edge of the road here, and there's a little bit of a differential. Look at that 0.079, 0.058. A couple of vertical edges. Again, they're so close, I'm just going to say exit and let it go and be done with it. Okay, so now we've built the surface. We've got everything selected, and the only thing we used were these lines and those points. And if we look at those, and oops, sorry. We look at those in our drawing viewer. That's all that we need to define that surface and generate those same contours. Now, if you notice, remember up in here where we had that long ramp that came down here off of that little loading dock area? Now let's notice the difference when we look at this one. Let's go back to view and let's restore layers. So it's down below the isolate layers. And that puts everything back on. And I'm going to also go to view and freeze layers by pick. I'm going to turn off those white lines and this set of points just to keep our display a little neater. And let's now go up here. We'll select some of their contours. We won't get all of them, just select a few. And we'll go back to view, 3D view, drawing viewer. So it's going to put those things we selected in the drawing view. And we'll go to model tab, close down the layers box. I'm going to add the first surface was our EG from contours. And our second surface is now EG from break lines and points. And let's compare the two. We'll go back to this, turn this off and back on to get the colors that we want. And let's look in particular at some of our problem spots. So back to the model tab, open up the surfaces, and let's turn off by double clicking the second one that we loaded. That's the one we just built. There is our first time where we did contours only and had the problems. And let's turn that one off and turn this one on. And now you see the difference. And there's a nice, sharp, crisp edge where that loading dock was. We've got another loading dock here. We have these, I'm sorry, I'm trying to get this to where we can see these parking lot curb edges. See these nice road curbs, wedge curbs, rather. So you can see they're down there along the line. They slant up half a foot up, and there's none of that stuff sticking out, none of those choppy chop things. Same thing over here in the road. Remember that nice road ditch? And we had that nice curb line on the sidewalk, and then there's the back edge of that sidewalk area. Again, up in here, some curb. So this compared to oh no. Turn this back on. There we go. So this one, you'll see that nice sharp crisp definition compared to this one. You can barely even see. Let's put this up here. Can't even really see much with it. because that was just built from the contours. So hopefully you can see and appreciate the difference and understand why we would do the extra care to model that surface, or to model those surface things. And then again, in here, where we had get some kind of weirdness going on here. Bear with me for a minute. Oh, probably I should start. Let's see. If I go to surface and now draw a triangular mesh and draw from this new, better made one and choose the that's not really what we let's see if I can find it in the lens. So that and last. I don't know if it recognized it as the last thing drawn. But it is. Anyway, my mouse is no longer working. Let's see. All right, so I need to actually exit this back into it. Let's take that.
Hey, Ken, you sound very far away. I can't really hear you anymore.
Oh, I'm so sorry. You are probably because of that. Now you can hear me okay? Is that better?
Yes, that's a little better.
Okay.
Yeah,
so
slightly better.
there's something going on with this system here. All right, so it doesn't matter there. I'm going to need to show this thing. Now, sorry about that. Was it, how long was it like that, sound wise? Just briefly or for a long time?
It was just like it slowly started the last couple of minutes to get lower and lower.
Oh, okay. Well, sorry about that. And apparently that was caused by this. Let's go ahead and open this up. Subjective flash. So what it wants to say. Open it. There it is. And I'll simply go to a save as and put this back in our previous spot, which was CARLSON projects. So the space that's sample from T3 logo. So, okay, so now we can do that surface. draw the surface, triangular mesh. There's my surface. I will draw the lines. I'll use this exclusion. And now, look at that. In fact, if I turn on all those layers, and I see, let's draw a selection set. Set. Let's draw this. So you see all of those. It's like this point.
I'm not sure if it's just on my end, but your audio's, I mean, not. It's very low for me and very spotty. And I tried
Okay. All right.
two sets of headphones.
Yeah, let me switch this. Let me put it back to this. I was trying to do some noise cancellation on that. I'll try to just be loud enough that you can hear it here with the air conditioner going. But anyway, all I was really showing with this is that, remember before when we had all of the triangle edges went to the vertex points where these contour lines had vertices, but now because we did not use them, where you seeing now things like these are those points. You see they're on this layer called mask points. So it used those, and it used all of the vertex points of these white break lines that really gave us that much greater fidelity of what the photogrammetrist actually produced. Now I'm going to erase those couple of little things there. And now if you've done your modeling accordingly with those two items, I'm going to now freeze off those, and let's draw the contours that your surface has, just so you can look at the contour difference. So let's go to the surface menu, and now because the files are already made, we don't have to go back to that triangulate and contour. We're just going to contour from a 10 file, so this third choice. And let's take the original that we did the first time. We'll open that. And notice we have those similar type tabs, triangulate, contour, labels. There is no selection tab. And my triangulate, this lets us do things like using inclusion and exclusion areas, that sort of stuff. I'll just basically leave those alone. I'm going to go to the contours and say, draw the contours every 1 foot and 5 foot for indexes. Topo minor, topo major is my layers. You can do whatever you want. I'm going to say no smoothing. And I'm going to turn the labels off for now, just to generate this. I'll say okay. And there now are our drawn contours, the red and white. And you see over here, those where we didn't trim out those triangles, it still generated contours. Now their triangle, or I'm sorry, their contour lines are also drawn. You can see it, for instance, here. Here's a place where we're not terribly far off from what they had, but look at, say, this contour line and this contour line of theirs compared to this contour line and this contour line of ours. You see those little spiky things on the edges. So there's some significant difference with some of that. Some of them are pretty close. Out in here, of course, was that big ramp that we no longer had or needed. So now we can also see some significant difference along those edges. So if we compared that one, that was the bad one. Let's go back to that same command, surface contour from tin file. And this time use the last one we just made. I'm going to say open. And I'm going to make sure it says erase previous contour entities. I'm going to say all contour entities, so it erases those other ones. And I'll say OK. And now this is what we get when we use the break lines and points that they use. And if I zoom around here, I can see a couple of little differences, like right in here. This one. And that is not a contour line, that's just a boundary that shows a brush area, so that's not a difference. But look at the significant difference in contours, like we no longer have that mess that we had earlier in there. We no longer have this ramp down in here. And you can see our red, their yellow or lighter green, our white and their darker green are really, really close to being the same set of lines. And again, they generated theirs from a completely different set of software than we did, but we are really faithful in modeling what that surface looks like when we use the right data. Okay, so keep some of these contours in mind, and when we start back tomorrow, we're going to start looking at some of these civil tools that allow us to do grading and roadway design, things that if we were doing it separately, and in fact, if you look back to this set of exercises in the front half of the book, for instance, find a place. This little example, we did a stockpile, and we did a borrow pit in the stockpile. And then we took all of those little surfaces and then designed an access road to come up and go into this area. And we manually selected the existing ground to generate a profile, and then sort of manually generated this road profile to sort of best fit that existing ground. And then we took that line, that profile line, and drew it into our drawing along this center line. And then we offset it, whatever that lane width is, 12 feet probably, and down 2%, so it has a crown on it. And we set that line, and then we use that to go out and find where it would, at a 3-to-1 slope, where it would intercept the existing ground on both sides, and then put that new roadway surface in along with that borrow pit, and merged it all in with that original stockpile volume, and it comes up with this composite surface. Now, all of those things in this set of exercises is done sort of on a nearly manual method. We sort of brute force created that 3D polyline, drew it, offset the edges, and built the road. what we're going to see tomorrow are the road design tools, where we're going to have a center line, we're going to have a profile, and we're going to define what that cross-sectional shape looks like in one spot, and we're going to then push it through our model, and it will take care of generating all of those break lines, edges. We do the same thing with ponds and building pads, any type of graded objects, just so that we know those specific tools and where they are and what they do. But what we've gone through today and what we've seen today is basically how it generates those surface entities from our 3D data. And there's really nothing more complicated than that. It gets a little more complex. And sometimes that we have to keep track of a little bit more. But that's organization, that's not capabilities. And so we're going to use the tools that are going to be best suited to what we do. And the reason that I say that is I'll show you just a little picture of what we're going to talk about here tomorrow. This will do some of our roads. We're going to take an example of a building and a parking lot. And we're going to generate the building pad and then the parking lot pad, and then we're going to cut it into that existing ground. And here's what's going to happen is if we look at the building pad first and we set it in, well, you see the blue areas are fill, the red lines are cut. So right in here on this back edge, it goes from that edge up to a 3-to-1 to where it hits the existing ground where it goes. And then once that's built, if we go to the parking lot and do the same thing, well, it's going to be a little bit lower than the building. Well, it's going to try to go up and find not just the existing ground, but the existing ground that now has had this building built into it, and it's going to hit it right along this line. Well, we wouldn't actually build this combination of structures in this particular fashion, would we? What we would do is, okay, there's the slope if the building was built by itself. Here's the slope if the parking lot was built by itself, but we don't need to come up to that crease line. We're just going to go straight between them. So we're going to go from, say, this point right here, straight down to this point right here. And we're going to follow that all the way along until we get out to where we no longer need to worry about that, where this is starting to fill, but we're going to trim that fill down to that edge of the parking lot. So you're going to see how we do that in terms of all in the world those things are 3D polylines. So we're going to be able to edit those 3D polylines and trim and move and select and snap and reconfigure that stuff. And once we're happy with that drawn as a stick figure, then we're going to treat it just like what we did today. And we'll do triangulate and contour to recreate that set of surfaces and create what our design intent is. And we'll see where things like roads are going to keep track of a lot of this for us with center lines and crossings and intersections and all of that. And there's some automatic intersection cuts and fills. And you can pick those alignments up and just drag them in plan view, and it will recompute all of those things as we go along. Much like, excuse me, much like Civil 3D does, but it does it individually from those, the fact that it's in the drawing, it's just CAD entities, but it goes out and reads the data and manipulates it all in memory. So that's going to be what we will look at tomorrow is some of those higher end tools and how they work. Now, I'm going to set this a little bit more like what that would look like. Now, when you get at the end of our exercise section, and we'll finish this little discussion point and then call it a day. But up here in the table of contents, we have all this upfront stuff. We have these things about the menus, like general versus modular menus, and these little file, edit, draw, inquiry, settings, and points, and modular, in this case, survey, civil, all the different menus that are in there, the different modules. But you see, they're all discussed on a single page, so that's not a lot of things on the menus. Then you're going to go through these concept areas and these exercises. And when you get down through this part of it, the next set of exercises are these civil exercises. Sorry. And that's where we had that the roadway design and our grading tools. And then when you get through that exercise, that was that part right here that we talked about, we get to the end of those exercises. And the next set is a command reference, starting with the general menus, and then you'll see the modular civil menus later. Now, this is where all of the menu choices, or at least the important ones, are explained. And you'll see it menu by menu. The file menu, and this goes through, again, all of the different menus. Here's the edit menu, for instance, all the different commands. Now, in using your book, here is something to sort of keep in mind. When you look at these menu commands that are shown in this back half of the book, these menus often have standard CAD tools like move, copy, trim, rotate, etc., as well as some of these CARLSON enhanced variations. And these are actually going to not list the standard CAD tools. So if it's not shown here, that's a standard CAD command. For instance, under the edit menu, erase, select, single, last, or even oops, those are standard CAD commands. They're not going to be in there. So the first one you're going to see is that erase by layer. And then erase by closed polyline and erase outside. We've got the temporary erase, and then it's going to go to the skipping move. It's going to go to copy and choose copy to layer, copy polyline section, offset to area. So it's going to go down through all of these different pull rights. Okay. Now, what this means, excuse me, what some of this nomenclature shows you here is if it is red and boldface, then that means just as I've used this software for about, I don't know, close to 25 years, these are some of the commands that I have found to be really helpful. And you might notice back here under the file menu, for instance, there's project, import, export, all those things are good. But here's one called drawing cleanup, and there's a lot of power in this particular single tool. Okay, so those are just some things to pay a little extra attention to. And you may find in your particular workflows that, hey, you use this rotate text all the time, and that's your go-to command. Well, that's great. That's not to say just because I've got it colored red and bold-faced that the others aren't important, so they are there. Couple of things as well, like on the draw menu. Yeah, here's one, for instance. The arc, and this is on page 87 of the manual. Under the draw menu, there is a arc pull right menu. It's got a number of tools inside of there that are typically like we think of things as surveyors and engineers. We talk about PCs and PTs and all that. So the commands are set up to do that. But all the way at the bottom is this command, for instance, called the curve calculator. So this curve calc, if I type that, if I choose that, it lets me fill in some information here. I might have a radius of 100 feet and a delta of, say, 45 degrees. Once I get enough there, it will compute the rest. I can even tell it to plot, and it will let's go in that direction. So there now is the resulting curve. I can also, if I have simply drawn a so I just do something like that. And now, if I have that calculator open, I can select anything that has an arc in it, whether it's a polygon with an arc segment or a drawn arc, and it will read and report on those numbers. You can generate reports, for instance. So here's all of that information. You can even plot that down on your screen. And so all kinds of different tools that you may not really be aware of being in here. So that's what that command structure is like. When you see those things that are red and bold, or to point out that are in some cases are little hidden gems. Draw by example, sequential numbers, just all kinds of different things. The inquiry menu, the drawing inspector, very, very powerful command that a lot of people aren't even aware is available. So make sure you take a look at those as you're doing your work. You don't have to do them in the first day, but flip through those things and try to see if there's something that might make sense. Okay? Makes sense to what you've done so far?
Yes.
Yep.
Any questions before I let you finally stop and take a breath?
Not right now, no.
Very good. All right. Well, if you think of any overnight or whatever, let me know and we'll discuss those. And anything else that you may have seen in the software that you might want to know about. Again, we'll take a few minutes to take a look at some of those other things as well. But what we'll be working on tomorrow then will be another couple of surface modeling things. We're going to basically take a file that has a surface already in it, a civil 3D file actually, and then we're going to work on the road design, and we're going to do some grading tools, and that'll be about all we'll be able to get in for the day. Okay. So I will send you later tonight a link to, actually I'll send it to you right now to make sure you get it. Go back to this here, copy the invitation, and let's go back to this, and I'll do a new bit, and oops, well, let's see, that and there, and there. All right, so this will be for tomorrow's come back to this. Paste there. And paste here. And we'll call that Carlson training civil date. Now, let me know that you got that, and then that you can use that then in the morning, at 9 o'clock when we get started. Okay, did that everybody get that? Okay?
Yes, I got it.
Okay, Matt.
I haven't, but it might get stuck in our like spam thing. I'll figure it out.
Right.
If
Okay.
I don't get it, I'll email you.
Okay. Yep. If you do not, let me know. You should get it. If not, just either send me back an email or call me. Either way, but make sure. Let's see here.
The last one got caught up in our spam, but let me. Yep, there it is.
Oh, you got it?
I got it. Yep.
Right. Good deals. I will see everybody
right.
tomorrow morning, 9 o'clock.
All right. Thank you.
You bet. Take care now.